Good morning to one and all. Welcome to day 2 of the 2-day national level e-conference on energy, environment and sustainable shipping organized by the School of Marine Engineering and Technology, IMU Chennai campus. We had 2 sessions yesterday and today we shall have the next 2 sessions.
It gives me a great pleasure to introduce the session chair of the third session. We are honored this morning by the presence of Dr. S. Mohammad Ali. He is a professor in Department of Mechanical Engineering, Pondicherry Engineering College. He is specialized in engineering design and tribology. His fellowship includes FIE, Chartered Engineering, MTSI, and MISTE. He pursued postdoctoral fellowship from Islamic University of Medina from Kingdom of Saudi Arabia. He has teaching experience of 24 years and 4 years of industrial experience in heavy engineering and production. His software skill includes SolidWorks, CATIA, MATLAB, Analysis, NCEESS, and MS Office. So, I'd like to invite Dr. S. Mohammad Ali to grace us with his thoughts and experience. Sir, please.
Oh, thank you, Ananda. Good morning to everyone. I first thank Director Dr. Raju Balaji of IMU Chennai campus and the organizers of two-day national level e-conference, Energy Environment and Sustainable Shipping. Thank you very much for taking me into the two-day e-conference. And I have been allotted to conduct the session of third session as a chairperson. For mechanical and material, it looks somewhat odd. Better you will have the mechanics and material, I think. I was expecting to pay papers from mechanics of materials or related to fracture mechanics, which is mostly involved in the shipping industry, or it will be better to be in the super alloys or corrosion resistant alloy. That's what I was expecting, but I found that wide area of papers which are come from additive manufacturing and some review papers in anti-biofouling, comparative studies and alternate fuels, and study of machining parameters for some machining operation and wind turbine and also in heat transfer. It's very difficult to adjust the best paper as a conventional process of in conference. But I request all the participants to use this forum and extract maximum benefit by presenting your papers and discuss with the audience and experts who are present now in this forum. It would be better. My idea would be, as far as shipping industry is considered, people should concentrate on corrosion resistant studies, especially through super alloys. And if it is mechanics and material, we should concentrate on fracture mechanics, where the mechanics, all the assumptions are removed, and that will be a wonderful study for the budding engineers and those who are developing the curriculum. Also, I have understood that this concept is missing, fracture mechanics. Though it is taught in the higher level, in the PG level, presently as per the AICTE, but especially in the marine engineering, we should start from the UG level. In that way, if the curriculum is modified, it would be interesting. And also, I request the participant or whoever hearing or taking part in this conference, try to delve into the fracture mechanics, an interesting area, and it will be very much applicable in the title of mechanics and materials. It should not be mechanical and material. Mechanical means it's a generic name, and it will cover everything in the domain of mechanical. So I am just limiting and I am giving my experience. From my experience, I am telling you that you should concentrate on the fracture mechanics, especially. I thought in this title we will be getting the papers in that area only, and I was also interested to learn from your end. I hope I found only one paper as far it's related to in this exactly focused on this title. But anyhow, people will be budding engineers should use this forum to understand and get experience, and so that they can develop this attitude and experience in presenting papers in the later part of their career. I hope everyone is present and all the people are ready to present. And it would be better, people should be, our participants should be little bit more serious during the presentation. And generally, I found that is missing in the other conference and most of the conference. So please, I request the participant to be more serious and introduce yourself and try to be focused on the point. And better, you can explain yourself if you, what is your contribution in the particular paper or presentation, so that the audience can post appropriate question, and you will also be in comfortable position. So I hope let us start this session and hand over the stage to organizers. Okay. Thank you very much. Let us start.
Yes, sir. Thank you, sir, for your kind words.
Okay.
Without further ado, I'd like to invite Sri Vingesh S. to present his paper on design and simulation of fins.
Paper on design.
I don't get, please share the screen. I don't see anything except that total people. Please share the screen. And organizer, I would have been invited as a guest, then only I can share my screen if there is any clarification or discussion.
Yeah, Professor, you can interact in between if you want.
Okay, no problem. But the screen sharing should have been enabled. So okay, no problem.
Yeah, copy.
I think we don't have that much time. Rose and silver.
The presenter can start the presentation.
Okay.
Good morning, everyone. We are here to present the design simulation of what?
Your voice is not clear. Your voice is not clear. Please, others, mute your mic so that there won't be any disturbance. Yes.
Okay. Okay. Good morning, ladies and gentlemen. We are going to present the first topic based on design and simulation of fins for frozen tail valve using buoyancy approximation of extended surface heat transfer. This project was guided by Mr. Sitanshu Sekhar Biswas in Bhavani, and we are submitted by myself, Venkatesh Rao, Vignesh, and Akash. So moving on to the introduction part. So basically the frozen seal valve is a great valve used to isolate the heat transfer system or heat exchangers for maintenance purposes. So this valve has a disc perfectly fitting in the valve seat provided with sodium pipes, which has primary as well as secondary sodium pipes, which is used in the nuclear power plants. So the disc attached to the cylindrical stem. The stem is covered by a sheet which itself is attached to the pipeline. There is a positive clearance forming an annular path between the stem and sheet. So moving on. Due to the pressure in the sodium line, sodium rises in the annular path. To avoid sodium leaking through this path, the sodium will be frozen in this path. To promote the freezing of sodium, heat transfer from the valve sheet is enhanced, providing circular fins attached to outer layer. And the freezing is achieved solely by natural convection method. And natural convection cooling of fins is passive, and hence it is reliable without the need of blowers, emergency power supply, etc. Moving on, this is the abstract. So basically, liquid sodium is the primary coolant and as well as the secondary coolant for fast breeder reactors, which is used in the industry. And the main drawback is of the sodium, liquid sodium, is its violent exothermic chemical reaction with atmospheric air, and its freezing point is high, which is 98 degrees Celsius. So we are isolating this secondary sodium system from the stem generator, and this frozen seal valve is used here. So the main objective of this valve is to avoid the leakage inside the valve, and certain special arrangements are made in this valve. And the frozen seal valve are also known as butterfly valves. To achieve sodium freezing, horizontal fins are attached to the outer surface of the valve sheath, and natural convection takes place via these cavities, which is investigated for further CFD analysis using various fin profiles. And the main aim is to do modeling by fins using analytical and simulation method, and to optimize better thermodynamical efficiency inside this valve. This is the literature review done by certain authors via various industries. As you can see, Hinoja P, Polet, Chananthian, and Veluswamy designed and investigated about various fin length and specifications through heat transfer coefficient rate and also thermodynamical efficiency of a certain fin type approximation using buoyancy valve. And this is the problem identification. So the main problem identified here is, as I told you earlier, sodium leakage occurs, and it's via exothermic reaction with the atmospheric air. It is seen that convective air does not penetrate deep into shallow cavities, leading to poor heat transfer coefficient. And the penetration depth of air is function of aspect ratio and Rayleigh number based on fin spacing, and it is independent of fin length. So this is the methodology. Basically, we are going to see preprocessor type, solver, and post-processor, where in preprocessor we are going to have the geometry specification, applying boundary conditions and mesh generation. And in the solver, we are going to identify the problem, and additional models and the computational design analysis have been used. And in the post-processor, we are going to compare these results using various cases, and finally we are going to generate a report. So the main scope of the study is carried out in two stages. We have CFD analysis. So using fluid flow inside these valves, and the temperature distribution will be carried out using an finite element modeling software called as COMSOL 5.3, and fin profile and root temperature will be varied as a parameter here. And also the various fin profiles will be analyzed for effectiveness. So, and the final stage, the results will be validated by taking experiment measurements of high efficiency fin profile using a proposed fin dimension. So we are going to see here three cases. The first case is the circular fin with conical cavity. As you can see in this diagram, there is a conical cavity inside this with a circular fin, which has a specification of fin length of 85 mm, height 753 mm, and since it is conical, it has outer as well as inner thickness, which is to be 20 mm and 10 mm, and the material is made up of stainless steel. And these are the domains which we have identified in the software. This is stainless steel domain of the valve, and this is the domain of the liquid sodium inside the valve. And this is the infinite air domain, which takes place between the fins and the atmospheric air in between the fins. And final one is the heat transfer domain, where heat transfer takes place between the fin and the valve. So moving on, these are the specifications for the certain domain. As we can see here, stainless steel 304L is the main property of this valve, and we are applying industrial properties which are thermal conductivity to be inputted as 20 watts per meter Kelvin, density to be 8,000 kilogram per meter cube, and specific heat as 504 joule per kilogram Kelvin. And the second domain here is taken as liquid sodium, and its properties of thermal conductivity is to be 98 watt per meter Kelvin, specific heat 282 joule per kilogram Kelvin, and density is 1008 meter Kelvin. So moving on. This is the meshing example of the software COMSOL 5.3 inside the finite element modeling method. And this is the stationary study. As you can see, below this annular part, the secondary sodium liquid passes through and sodium freezing takes place on top of it. So there will be a maximum temperature on below. Till the freezing occurs, it will be a minimum temperature at the top. We're going to see each case like this. And this is the contour temperature on the front axis. So the result for the first case is to have the latent heat from liquid to solid is 26 kilojoule, and the phase change temperature is to be 371.15 Kelvin with transition interval of 10 Kelvin. And the convective heat transfer coefficient is found out to be 1.9 watt per meter square Kelvin. And the contour temperature distribution of frozen cell sodium valve, it is clear that the minimum and maximum temperature, as I told earlier, is to be 305 Kelvin and 429 Kelvin, where 429 Kelvin is the inlet temperature, which is the maximum at the bottom of the frozen cell valve. As sodium freezing takes place, the minimum temperature will be, of this case, will be 305 Kelvin. And this is the graph of sheath length and sheath temperature in this case 1. And this is the another graph of sodium temperature and sodium pressure of the case 1. And moving on to the second case, which is circular fin with rectangular cavity. It has the same specification as of earlier, case 1, which is circular fin with rectangular cavity. As we move on, the contour temperature is same. And in this results, we are going to identify that latent heat from liquid to sodium is 26 kilojoule per kilogram, which is same as of earlier case, and the same phase change temperature 371.15 transition interval of 10 Kelvin. But here we are getting an enhanced convective heat transfer coefficient, which is found out to be 2.4 watt per meter square Kelvin, and even the temperature of maximum and minimum, which is also known as inlet and outlet temperature of this valve, is to be 299 Kelvin and 429 Kelvin, which is quite different from the previous case. And this is the graph of sheath length and sheath temperature for this second case. And this is the sodium temperature and sodium pressure graph. And the final case is that square fin with rectangular cavity. So in this case, we are identifying the height and length and thickness is to be same as the previous two cases, but the structure is different, as we can see it is a squared fin, and it has the contour temperature similar to that of these previous two cases. And here we are resulting the convective heat transfer coefficient to be 2.35, and we can see this minimum and maximum temperature rise will be 299 and 429 Kelvin, which is quite similar to the previous case. And the computation time taken place in the finite element modeling inside the software is to be taken 23 minutes per 25 seconds, which we have got it in the software. And this is the graph for the sheath length and the sheath temperature. So final simulation results, we got in these three cases, the heat transfer coefficient for case 1, which is circular fin with conical cavity, is to be 1.9 watt per meter square Kelvin. And for the case 2, for rectangular cavity, circular fin, we are obtaining 2.4 watts per meter square Kelvin. And for the final case, we are having, for the square fin, 2.35 watt per meter square Kelvin. So as we can see, we can result this second case is been having the highest heat transfer coefficient. So we are taking this second case and utilizing in the industry for experimental purpose. And this is the experiment setup used in the industry. As you can see, the circular cavity fins are used here. And this is the experimental versus CFD plot. So we can see it is quite similar as we obtained in the software as well as in the experimental practical setup in the industry. It is quite similar. And moving on to the final conclusion. Thermal analysis of frozen cell valve used in secondary sodium lines of PFBR has been carried out to decide variable fin profiles. So based on this study, we are obtaining the temperature distribution of various fin profiles and determining it. So we have, as I told earlier, second case which has highest heat transfer coefficient is opted as the best designed experimental analysis. So its inlet and outlet temperature is to be taken as 429 mm. Minimum temperature is 301.2 Kelvin. So this is the practical analysis taken in the industry. So freezing of the sodium leakage will be arrested here. So the design setup is quite good, and better thermodynamical efficiency is obtained in the industries. And the minimum and maximum temperature for CFD experiments are supposed to be 429, 299 Kelvin, and 429 and 301.2 Kelvin, which is drastically similar, quite similar. So these are the experimental and the CFD analysis taken in the software as well as practical setup. So these are the references in this project. So we have identified basic authors and checked upon it, and finally utilized this project with the help of our guide, Mr. Shitanshu Shekhar Biswas. And thank you, sir.
Mr. Rakul?
Sir? Yes, sir.
Only yourself, you only presented, na? Is there any team members along with you? Can you please switch on
Team
your
members
camera?
are there, sir, but
No, just
sure,
ask me. Switch on your camera, sir.
Sure, sir.
Yes. Only yourself have presented, or is there any other team members with you?
Team members are there, sir, but they are not able to connect the audio, sir.
Okay,
They're having the problem.
Okay.
Yes, sir.
Due
to lack of time, I am presenting myself, sir.
Okay, no problem. Just I am asking you. Okay, will you please present that comparative result of experimental and mathematical analysis, I mean software analysis. There was one slide. No?
Sure,
Why did you go with the MS Office
yes,
slide? It seems you have run with Google slides.
Sir. This graph, sir, experimental versus CFD plot.
Really. Okay. I understand you are the student of UG or PG?
UG, sir.
Okay. What?
Completed my final
year. You have completed. Yes, okay. Because we should know the
yes, sir.
candidate. Now, then only we can question you. That's why your introduction should be clear.
Sure, sir.
That's all.
No problem, sir.
Okay.
Yes, sir.
Have you done any manual work? I mean, calculation of basic thing of to go for this type of analysis. What was the problem you have taken for basic study? This is just a film. Okay, environmental conditions are different.
Yes, sir.
But what was the basic problem you supposed to study to take up this analysis?
Basic problem in the industry, they have explained these.
I am asking within your domain. I mean, in the context of UG study, what was the problem which are similar to this one?
In this project, sir, we're asking about
similar to this one. You have studied one. You have just completed BTech.
Yes, sir.
That's why I'm asking you. What is the similar problem which you have come across or encountered in your study?
We have crossed this fluid mechanics as well as thermal engineering, sir, and basic thermodynamics, sir.
Any specific problem?
Specific problem, we have used this Fourier's law, sir. Basics are the Fourier's law, which we have studied in our thermal engineering as well as thermodynamics, and we are applying these laws with certain calculations inside the finite element modeling softwares, and identifying the numerical computation methods using different formulas.
It starts from the simple film problem which you have come across in the thermal study, thermal engineering.
Thermal engineering.
Same thing can be extended to three-dimensional. You have studied
Yes,
only
sir.
in
Three
one
dimensional.
dimension. That's what I was.
Ah,
Have you done any mathematical manual calculation for this problem also? You have
no, sir. We
compared with
haven't. Sir. Ah, we
any
compare.
software or any analysis should be start with the scratch means start from the scratch means you should do some basic problem. How can you rely on this software whether it is giving the correct result or not? First, it should you have to do some manual work. Manual means closed form solution. You should approximate the model as very
Yes, sir.
simple, and the same solution you should get in the software also. Have you done
Yes, sir.
anything like that? You
Ah,
please start. And this is just a tip to
okay, sir.
consolidate your position and to defend yourself. If you are presenting anything, the basic problem should be done in manually as well as in the software. Because ANSYS or COSMOL will give result for anything.
Yes,
How
sir.
can you rely on this result is based on your numerical study or closed form solution by making the model as a very simple approximation. Instead of taking this as a number of things, you can take a simple cantilever beam.
Yes, sir.
That extension to three-dimensional in circular direction, it becomes a film. And you
Yes, sir.
arrange in the y-axis, it will become the exact problem what you are doing.
Yes, sir.
So you should have enough uh, data, or you should be able to defend yourself by posing the very basic problem. You please prepare in that way, so that
Ah,
it
sure,
will
sir.
enhance your knowledge in this area also.
Sure,
And
sir.
is exactly with the experimental and CFD study are almost exactly matching. Have you
Yes, sir.
any percentage variation is how much? It was less than 2.5%. It was like that, or what was the percentage variation of error with experimental study and CFD study? Do you have any data?
Right now I don't have, sir. That's why I'm
Okay.
sorry.
These are the things you're supposed to pose
Yes,
when
sir.
you compare the experimental and the study.
Sure, sir.
Okay, thank you.
Thank you, sir.
Thank you.
Now, moving on to the next presenter, I'm gladly invite Dr. R. Viswanathan for the next presentation.
Yes. So good morning to honorable person here. My screen is visible, sir.
Yes.
Yeah. So good morning to honorable person here. So I am Dr. Viswanathan, Associate Professor, Department of Mechanical Engineering, so Pallavi Engineering College, Hyderabad. So today I will present about my research paper, investigation and optimization of turning parameters on surface toughness in machining of magnesium alloy. So the main advantage of why I choose magnesium alloy means so magnesium alloy is one of the lightest material. So mainly it is used in aerospace, aircraft, so automobile. Sometimes it will use laser medical. So mainly we focus study on cutting parameters of magnesium alloy. So is a 91D category in dry turning with the uncoated cemented carbide cutting insert is used. Okay. And also we analyze the effect of each turning parameter on the surface toughness. So using the Taguchi method. Also it was concluded, we found that so mainly among the three cutting parameters, cutting speed has the greatest influence on the surface toughness. Okay. So introduction. So magnesium alloy has a density of 1.8 gram per cubic centimeter. So it has a very less weight. So comparing to the aluminum, it is less weight, around the 35%. Comparing to the steel, it is less than 75%. So and also it has several external properties. So high stiffness to weight ratio. So that's why it's mainly recommended for utilization of automobile and aerospace industries. And the main drawback of in machining a magnesium alloy is so during the machining, the chip can easily auto-ignite because its auto-ignition temperature of magnesium alloy is lower than its melting temperature. Its auto-ignition temperature is 430 degrees Celsius. Its melting temperature is 680 degrees Celsius. So while machining, if a cutting zone temperature reaches nearly 480 degrees Celsius, the chip will be automatically ignited. So to avoid that problem, so we have to analyze the machining in machining conditions. So for that only we selected the different cutting parameters. So the main aim of this research work is to identify the most dominant factor and the interaction which influence the dry turning of magnesium, and also mainly consequently we select the optimum turning conditions that produce a minimum surface roughness value. So in this experimental, we selected a test material A is a 91D magnesium alloy. So machine tool is a kiloscut unmaster lathe tool. So cutting tool is uncoated cemented carbide tool. So the measuring equipment, the surface toughness is measured using surface tool level, submitted by surface toughness tester. So the cutting condition we selected for the dry turning. So cutting speed in the range of 40, 60, 80 meters per minute. So feed rate, so 0.1, 0.2, 0.3 mm per revolution. So depth of cut 0.5, 0.75, so 1 mm. So we selected this as a cutting conditions. So once the cutting condition selected, we conducted experimental work on the lathe machines. This first picture shows the turning of magnesium alloy. So after turning using the surface tool level equipment, we have measured the surface toughness around the machining surfaces. So normally we selected the 3 value we measured. After measuring the 3 value, the average value considered for the evaluation. So based on the 3 factor 3 level, so we selected L9 orthogonal array. So we constructed L9 orthogonal array. So based on that we conducted the experiment. So after conducting experiment, we measured the 3 roughness value. Among the 3 roughness value, the average value taken for the further analysis. So after conducting experiment, so we analyzed roughness value using the Taguchi method. So we found that the response table using SN ratio. So based on the SN ratio table, so we can say the cutting speed, the level 1 have the max better value. So in feed value, so level 2 have the maximum value. So depth of cut, so level 2 have the maximum value. It represented the maximum SN ratio value get the optimum turning parameter for the machining the magnesium alloy to minimum surface toughness value. So pictures show the main effect plot for the SN ratio. So based on the reference table, the main effect plot is plotted. So after conducting the experiment, so using the response surface methodology, so we developed the second order quadratic response model for the surface toughness value to predict the roughness value. So based on the response table, response graph, so we got the optimized cutting parameter for the turning of magnesium alloy. It shows the cutting speed of 40 meters per minute, so feed rate 0.2 mm per revolution, so depth of cut 0.75 mm. So based on that optimized cutting parameter, we conducted the confirmation experiment. So we got during that confirmation experiment, we got the minimum surface toughness value 0.22 micrometer. So the main conclusion of this work is we found that the cutting speed is the main dominant factor on the surface toughness, so comparing to the feed rate and the depth of cut. And also from the regression analysis, a prediction model is so developed for the roughness, and also the predicted value has good agreement with the measured output responses. So based on the surface with the optimal cutting parameter at 40 meters per minute, so feed rate 0.2 mm per revolution, so depth of cut 0.75 mm. So these are the reference we followed for the research work. So main thing is, so mainly the magnesium alloy, mainly used in the aerospace and automotive and electronics, medical and householding equipment, because it has a very major advantage of this magnesium alloy. It has a low density, it's a very specific strength, it's a lightweight, the external corrosion and oxidation resistance. And also nowadays all the automotive aerospace industries mainly focusing the weight reduction in the particular industries, increase the fuel, reduce the greenhouse gas emissions. Most of aluminum are magnesium alloy nowadays are using medical industry as an implant material. So mainly it is because it's less density and also it has a good biocompatibility property. So thank you, sir.
Okay. This title slide.
Yes, sir.
Please show the title slide. So you have conducted some experiments also.
Yes, sir.
Okay, in what way that roughness affects the in application? You are optimizing the roughness.
Yes, sir.
In what way that roughness affects in application?
For example, in medical implant, the medical implant should have the high surface finish is required. If roughness is poor, means it will easily affect the human health in medical field, and also in automotive field, wherever the higher surface finish is required, we have to completely reducing the surface roughness value.
Okay, you are expecting that roughness should be quantified accurately. Is it not it?
Yes. Yes,
Your point of discussion is roughness should be quantified very accurately.
Yes.
Because you are
Yes,
discussing in terms of medical as well as in engineering also, that should be nanoscale. Do you think that roughness
Yes,
parameter only what you have done is enough to quantify? Is there only one roughness parameters or is there any other parameters are available? I mean, you can, in layman language, you can say that the length is measured in meter. Okay. Likewise, roughness is measured in only in the RA value, or is there any other parameters for roughness? Quantify the roughness. Have you come across?
in my work only quantified RA values.
That's why I'm asking you: is it enough to quantify the roughness accurately through RA value?
Some RT value also there, sir, but in my work only RA only we considered.
Okay.
But other roughness value also there.
As you have come across many literature survey, have you come across any other parameter to quantify the RA? Quantify the roughness other than RA?
Okay. RT also they measured.
No. Okay, but you have to explore this one because the application is in medical field. It should be because RA is only a two-dimensional measurement. You are taking some sample length and the probe will be traveling for some centimeter distance. Based on that average, you are taking the RA value. But what about the other direction? What about the other direction? So it is not a complete parameter to quantify the RA, first of all. That is the weakness of this experiment. There is the biggest weakness in this one. If the application is in the area of nanoscale or microscale, this RA value is not enough to quantify the roughness. If the quantifying the roughness only through RA is not enough, then our total work will become waste. Understand? So you should explore the other parameters which are related to roughness. To my knowledge, there are 14 parameters to quantify the roughness. Two-dimensional parameters and three-dimensional parameters are there. Nowadays, people are only quantifying with the. Have you come across any roughness measurement instrumentation system? How did you measure the roughness? As a teacher, I am asking you some more questions. That's all, nothing else. Have you come across any other roughness measuring instrumentation system in your work?
Only one, sir. Meter roughness tester only. Only one only.
What was the accuracy of that experiment setup? Measurement system. What is the accuracy? How least you can go for measurement in roughness?
Micrometer level only, sir.
How many microns? Okay, you have to be thorough with this one in presentation. Okay. There are 14 parameters. Why don't you explore in the other RA parameters to quantify this one? Because that should be limited based upon your application. That's why I'm asking you what was the application. If it is in the application is in the medical field, you have to rely only on the three-dimensional parameter range. Not this machining will not be two-dimensional parameters, will not completely quantify the roughness. Keep in mind.
I will accept it.
So you please explore this area. First of all, you don't accept that RA. Somebody has done with RA, so I will also done with RA. That's not enough. What is the problem in only quantifying through roughness? First, you please explore it. Then extend your research in the. Why don't we include other parameter? If the other parameters to quantify the roughness itself, then how it can be improved? That is one command. And second one is all this experiment you have done only 3.
Yes, sir.
3 times.
3 times we
Why
repeated. 3 times.
3 times 3 experiments.
Yes, sir.
Only 3 values, parameters. Why should not be extended to number of experiments be increased to more? What is the difficulty? It seems to be very minimum. Minimum is 3 point required. That's all. What about the trend? How to predict the trend requires more experiment. What is the problem in conducting more experiments? The cost, or what is the constraint in it?
If increasing the experimental cost will increase, time will increase. Sir.
That is everybody, everywhere it is there. Okay, you please explain. These are the comments.
Right.
Thank you.
Okay, sir. I will accept. Sure. Thank you.
Okay, next please.
Moving on to the next presentation. Next presentation is on design and fabrication of serious wind turbine for electricity generation by Sri Sravanan JP.
Good morning, everyone. Are you seeing my screen? Okay, my project is a design and fabrication of a 7S wind turbine for electricity generation. I did this project under the guidance of Mr. Sitangshu Shegar Biswas and myself, Saravanan. So we will move on to the project. Introduction: for solving the world energy problem and the bad effects of conventional sources of energy on environment, special interest is paid towards wind energy because of its competitively. And as the wind energy is one of the renewable source of energy, we are using it extensively for the green energy source. So we can obtain the kinetic energy of the wind to electrical power by using the wind turbine. There are 2 types of wind turbine. One is horizontal axis wind turbine and another one is vertical axis wind turbine. My scope of study is vertical axis wind turbine. So vertical axis wind turbine are a type where the main rotor shaft is set transverse to the wind while the main components are located at the base of the turbine. That means unlike the horizontal axis wind turbine, which will have the generator and every mechanism at the top of the tower, the vertical axis wind turbine will have every generator and the components at the base of the turbine, so we can easily maintain and we can easily erect at a low cost. And it doesn't need to be pointed towards the wind, which removes the need for wind sensing and orientation mechanism like yaw mechanism. And types of vertical axis wind turbines are 7S, Darius, and H rotor. My type is 7S wind turbine. This is the 7S wind turbine. It's the wind turbine actually looks like a shape when viewed from the top, and it is actually invented by the Finnish engineer Sigurd Savonius in the 1920s, and it is one of the simplest wind turbine designs. Okay. The working principle: the 7S wind turbine consists of 2 to 3 cylindrical blades that employ a drag action to convert wind energy into torque to drive the turbine. Due to the curvature of the blades, the turbine encounters less drag when moving against the wind than with it, and this causes the turbine to spin in any wind regardless of phasing. So we can see the diagram. When the wind is hit the concavity of the blade, it will make drag. It will make a pressure difference, and it will produce the drag. So the wind turbine will rotate in the direction of against the direction of wind. So it will experience low drag, and the rotation will convert into the electrical energy. This is the 3D model we have did. This is the main parameters. This is the shaft, D diameter of the shaft, D the total wing spread of rotor, E overlapping ratio, H height of blades, wind speed, and diameter of end plates. This is the main parameters for a wind rotor. This is the rotor design. Every wind turbine has to follow the Bitt's law, which defines that every turbine can only be captured 16 by 27, that is 59.3% of the kinetic energy in wind. The factor 16 by 27 is known as Bitt's coefficient, and this is the shaft power, PS equal to 1 by 2 rho A dq into Cp. Rho, I have taken the density of the air as 1.2 kilogram per meter cube, and area sweep area of the rotor blade H into D, and Cp, the Bitt's coefficient 0.593, and the velocity of velocity of air. So after applying the coefficient and the density of the air, I obtained the shaft power equal to 0.18 into H into D into V cube. We have gone through several literature surveys for the optimum design of the wind turbine. So, from study of improvement of Savonius rotor performance, we have obtained 2-blade rotor is more efficient. That means one concavity and convexity blade is enough to obtain more efficient energy. And double-stage rotors have higher performance. And the rotor with N blades gives higher efficiency. And another paper is a new design of Savonius wind turbine, which provides the optimum overlapping ratio is 0.77 and the optimum aspect ratio is 0.162. Factors affecting the rotor design is number of blades, number of stages, overlapping ratio, and aspect ratio. This is the theoretical design. We assumed the power of shaft power should be the 5 watt and the velocity of the air wind should be the 4 meter per second. And optimum conditions, as we obtained from the above literature survey, alpha equal to 2.24 and beta equal to 0.162. From that, aspect ratio equal to H by D, so is 0.77 D. From that, we obtained the rotor diameter is 0.28 meter and the height equal to 0.19 meter. This is eccentricity value 0.07 meter, and we obtained the radial velocity is equal to 11.42 radian per second, and we have considered the tip speed ratio as 0.8 for Savonius rotor. From the above calculation, we obtained the height equal to height of the rotor should be h equal to 0.8 meter, rotor diameter 0.56 meter, blade diameter 0.28 meter, and the end plate diameter 0.56 meter, and shaft diameter will be 0.03 meter. Application, it can be erected in any place like a hilly areas where it will require a huge infrastructure, but it does not require that much infrastructure to erect. So it can be used for remote electrification and household electrification by low cost wind energy system, and used in areas where cost or reliability is important than efficiency. This is the process layout. Wind turbine. The wind turbine will coupled to motor or generator, and the power from the motor or generator will be passed through the controller and to the device and the converter. This is the fabricated design, and this is the demonstration of the wind rotor. As you can see, we are producing enough energy to light a 10 watts bulb. And this is the DC motor output versus inverter transformer output. Okay, thank you everyone.
Sir, you are mute, sir. Please unmute yourself.
Mr. Saravanan, thank you.
Yeah,
Are you
thank
a
you,
UG
sir.
student or PG student?
Yeah, I am a
There are
UG
three.
student, sir.
There are three people in the paper. One is Mr. Biswas and Bhupati and Saravanan. You are
Yeah,
Mr.
yeah, yeah.
Saravanan.
Yeah, yes, sir.
Okay. You have manufactured the total unit.
Yeah, yeah,
Am I
yes,
correct?
of course, sir. Yeah.
Oh. Have you compared with any existing turbine, or just you have manufactured this one and you are saying this is the performance, right? Did
Yeah,
you compare with the?
no, sir. Actually, we just fabricated and we obtained the
Anything?
results.
That's why you should have the. How will you justify that this is best or good? How can you defend yourself? It should be compared with the existing one. Do you get my
Yeah,
point?
yeah, I'm getting my point, sir. Actually,
Okay, nearby. Okay, equivalent or similar turbines are there. Is there any turbine equivalent to this one?
yes, of course, sir.
Okay, anyhow, you have to focus in such a way that it is much better than this one. So comparative study should be there during any presentation so that you can justify your claim. One thing.
Yeah, okay,
And
sir.
my other comment is that have you done any design studies for selecting these sizes?
Sorry,
Okay,
sir.
next. You are selecting some size.
Yeah,
Based on
yes,
some
sir.
design, based on design or availability. How did you
No,
select the
based on
parts?
design only we have manufactured this, sir.
Oh, exactly. You have based on the some scratch design work has been done.
Yeah, yes,
Okay.
of course, sir. Yeah.
Okay. What about the total cost?
Actually, it comes around 2,500. Yeah,
Total unit.
2,500 or 3,000, sir.
No. From the total unit till at the end of the receiving power, electrical power, how much would be the cost?
Yeah, but actually it comes around 250 rupees per watt, sir.
That's why I was asking.
Yeah,
That
it's
is
costly.
yeah. Okay, then you can propose a way how it can be reduced also, in which way it can be modified so that future works or anyone going through this one can involve in that area. Okay, that is also your presentation. Because
Yeah, sure, sir.
the biggest point, power, how much is the power generation cost is hidden. Because immediately people, if alternative energy means immediately people will be looking for that one only. Then you have to
okay.
project the cost. Okay,
Yeah,
that also be
okay,
there.
sir.
Research
Yeah,
is
okay,
a
sir.
research, but you should be exposed to all the constraints and the weakness also. You have
Okay,
done
sure.
something, but don't project only the positive side because people will be, next question will be that one only. Alternative energy,
Yeah,
and what would be the cost?
yes,
Okay,
of course, sir.
that should also be presented. Okay, thank you.
Okay. Yeah, thank you very much, sir.
Thank you.
Yes, sir. Thank you, sir.
Thank you.
Now, I am happily inviting Shri Anirban Bhattacharjee for his next paper.
Hello, sir. Am I audible?
Yes, sir. Go on.
Good morning to esteemed chair of our session and all notable presenters. I, Cadet Anirban Bhattacharjee and Cadet Saptak Bishas, second year students of Indian Maritime University, erstwhile DMET, are privileged to be given this opportunity to be a part of this August gathering. We would present our paper, which is a culmination of an extensive review and research done on the modern advancements in eco-friendly anti-biofouling in the marine industry. Our paper is vetted by Shri S. Chakrabarti, a faculty of IMU Kolkata campus.
Fouling causes immeasurable damage to vessels if left unkept. The best solution is to use a quality reliable anti-fouling specific to the needs of the vessel. The course of fouling and solution by seated fouling is caused by the growth of barnacles and other marine organisms on the bottom of the ship. And fouling occurs on the submerged surface of the marine vessel at the moment it is submerged, generally when it's stationary. The growth of fouling has an immediate effect on the boat's speed and performance. the friction between the boat and the water increases, and this reduces the speed and in turn results in higher fuel consumption and higher expenses. The hull, propeller, and rudder of the vessel are where fouling occurs most severely, and thus it affects the throughout sail lot economically and in other aspects too. Due to the distinct chemistry and biology that determines what prevents them from settling, organisms are also classified as hard or soft fouling. Organisms with less adhesive power are grouped under soft fouling category like slime, etc. Here, organisms with most adhesive power are grouped, like barnacles, tube worm, etc. This category of organisms play a major role in fouling, leading to increased weight and drag force. Here in this slide and the following slide, we basically present an anti-fouling timeline where from we show the evolution from being a fancy paint to nanotech supervised anti-fouling, and in between we get various other several technologies like TBT paints, which is tributylene. We get the copper based paints, we get LSC paint, which is low surface energy paints, then STC paint, that is surface treated composites, and several other bio inspired methodologies. TBT, tributylene, is a biocide which prevents the growth of algae, barnacles, and other marine organisms. It was phased out from 1st Jan 2008 as TBT effects on the endocrine system of marine shellfish. It also impairs the immune system of organisms. In case of copper-based paints, those were mostly based on cuprous oxide. None of the copper-containing paints meets the 0.5% copper max limit as described in RCW 70.300.020, where RCW stands for Revised Code of Washington. It is a biocide-free, low surface energy siloxane elastomers and fluoropolymers that may provide an alternative to control biofouling. Silicon-based paints are not toxic to any organisms. It creates a non-stick surface similar to those known in Teflon coated. But best practice LSE coatings leads to barnacle adhesion strengths by 10 to 20 times, that is lower than Teflon. Then comes the STC, surface treated composite coatings that uses embedded glass flakes and achieve a hard outer finish. While sailing, all this marine growth sticks to our boat, like algae, mussels, barnacles, etc. So to prevent that, we get a fancy coating. Unfortunately, this coating only works when we are sailing and fully protects the boat for 6 months. After that, once all this growth attaches to our boat, that just gets slower and uses much more fuel. And on top of that, to make this coating work, it uses dangerous chemicals that kill marine life.
As stated by Alfred Lord Tennyson, we cannot direct the wind, but we can adjust our sail. Keeping up with this quote, let us dive on to the most recent and best eco-friendly solution that can be implemented in the marine industry. The modern advanced eco-friendly anti-biofouling advancement that we would imply is the silicon-based material covered with mushroom-shaped microstructures, essentially pillars that bulge at the top. The bulges create an upward force on water droplets that prevents them from collapsing into the space between the pillars, keeping the cavities dry. By contrast, on a similar surface with micropillars, without the mushroom-shaped-like structures at the top, the water flows into cavities between the pillars. A surface that resists the wetting reduces the contact area between the barnacle and the surface, resulting in a weak bond. They are then knocked off by the forces such as natural currents and water flows created as the boat moves forward. It will form an adhesive foil with fibers that create a textured surface. The foil will be attached to the hull of the boat and instead of killing it, prevents the biofouling organisms from attaching to the hull. It does not need any upkeep. It works whether we are sailing or in the docks and lasts for many more years. And because of the fiber, it helps in smoother water flow and we don't lose any speed and don't waste fuel and is eco-friendly as well. Our solution to the above nanotechnology film is the main target is to combine the concepts of super hydrophobic surfaces and mushroom shapes. As both are experimentally feasible in the marine industry, into better the anti-fouling by replacing the silicon mushrooms with the hydrophobic silica, which is a form of silicon dioxide. This will result in the formation of a more robust surface, which will retain for a longer amount of time. In the picture, we have shown how we want to implement the hydrophobic layer of PEO block instead of the mushroom shapes, so that it will be more robust and retain for a longer amount of time. We have not provided any experimental data because we were not able to do that, being at a UG level. But if given the opportunity, we would always like to enhance our research and go to the experimentation. Thank you so much.
Okay. This is Mr. Anirban Bhattacharya.
Yes, sir.
Okay. So totally it's a review paper. No? Generally, you have studied all the possibilities.
Yes, sir. We have reviewed all the processes, and at the end, on the nanotech coating, we have added to a new hydrophobic layer that might be implemented, which will better that process.
Okay, good start for your research career also. And my comment is regarding this one. People are concentrating on paints, I think, with the surface modification. And so better you can go through, involve in that area where how the surface roughness can be modified through different paints so that this can be prevented. That's what, as far as my knowledge is concerned, that would be the best area which combines engineering and chemistry. But I just want to get it clarified. And in your paper, it has been mentioned that injecting chemicals through those pores and regular intervals to completely resist the accumulation means actually, could you please throw some light on this sentence? Injecting chemicals through those pores at regular intervals. Actually, what is happening? Can you explain that one?
Actually, sir, what happens when the barnacles and other particles, they try to get attached with the surface, basically in the combined mushroom and hydrophobic silica, what they combining, what they does is that they firstly they do not provide any proper surface for them to attach. In case of after a long journey, if they get some scope, then that hydrophobic silica, what happens, there will be a chemical reaction between those adhesion or that addition, which is basically known as GOP.
Mr. Anirban Bhattacharya, my question is injecting chemicals through pores, how it is done?
Actually, that injecting chemicals, it basically means the hydrophobic silica which is present in the material, it reacts with that addition material, that it dopa with that, and then it prevents it.
No, permanently it will be there in the paint itself.
Yes, we have mentioned that the mushroom pores will be made of hydrophobic silica. Then that means it will be there.
No, my question is injecting chemicals through those pores at regular intervals. This was the sentence. That's why I just want to know how it is achieved. Okay, you please go through your paper again, and you can make it yourself comfortable when these type of questions are posed. That's what I can. Okay, otherwise it is already there. I received your abstract and it has been mentioned injecting chemicals through pores at regular intervals means I am wondering how it is done. Or I just want to know how it is happening. Okay, thank you.
Thank you, sir.
Thank you, sir. Okay.
Does any company market such products? Mr. Anirban.
Few companies, they have came up with that fiber process, like you will get a company named Seagate, which it's basically an experimentation, and various institutes carry on with this experiment. And company like I just mentioned, Seagate, there is a company which markets some fibers like this.
And second of all, glow fouling is an initiative of IMO, International Maritime Organization, along with UN, who are working hard on anti-biofouling materials around the globe. Glow fouling is trying to come up with such a solution, but of the microstructures and nanofiber coatings. So it is under research right now as well.
Okay, people are waiting for the next session. Can you start?
Now I'd like to invite Shri Anuj Kumar Chauhan for the next presentation.
Good morning, everyone. I am Rahul Singh and my friend Anuj Kumar Singh. We are honored and excited to present our views on alternative fuels. So let's begin. Alcohol.
In this paper, we are basically going to discuss about alcohol fuels, biodiesel, carbon neutral and negative fuel, hydrogen, natural gas, LPG and CNG, P-series fuel, and naphtha as a fuel. As we know, anything that we can burn to produce thermal energy is known as fuel. There is a huge problem of high fuel price, air pollution, and depletion of fossil fuels. This review paper covers.
Sorry for interruption.
Better you can check your layout of the screen. How to
You can
modify
present as full screen, no? Only the slides are visible. Could you present on full screen so that everybody can look into your presentation?
You change the layout. You change the layout.
So now is it visible?
It's okay. Okay.
Hello.
Yes. Mr. Rahul Singh, you can go ahead. Share your entire screen and select appropriate tab. That would be better.
So is it visible now? Is it
visible, but your screen is not. I request you to share your entire screen, then accordingly select the appropriate tab.
Okay, sir. Okay.
It's already 11:10. We are going beyond scheduled time and people are waiting for the next session. Take care.
So now is it visible?
Yes. You just follow this one. I think you are using Google Meet only. I mean, MS Office. We are using Google Meet. So you can present your entire screen, then select appropriate tab. That would be better. There is an icon bottom corner, press now, and in that you select the entire screen.
Is it visible, sir?
Yeah. Now it starts visibly. Yes.
Yes, go on.
Here we are going to discuss about properties of different fuels. First one is alcohol fuels. Methanol and ethanol are primary alcohol fuels. Alcohol fuel can be used as a pure fuel or blended mixed with different fuels. in internal combustion engine. Generally, ethanol has high octane number. We can use alcohol to be blended with other alternative fuel to improve energy density. It burns cleaner than gasoline and diesel fuels. Now about biodiesels. It is made from animal fats or vegetable oils, renewable sources that come from plants. It can either mix with pure diesel or make various proportions or used alone. It releases a small number of pollutants than diesel because it can burn cleanly and more efficiently. Now about carbon neutral and negative fuels. It is synthetic fuel produced by chemical reaction between waste carbon dioxide recycled from power plants or derived from carboxylic acid in seawater. It has no net greenhouse gas emission or any carbon footprint. Now about hydrogen. Hydrogen is a clean fuel and less heat loss occurs during hydrogen burning. But hydrogen has some disadvantages such as very low ignition energy or volume energy density. It is mixed with other fuel, especially with natural gas to use in a spark ignition engine. As we know, H2 reacts with oxygen to form water and releases energy. And in case of natural gas is generally consisting of methane 85 to 96% and contains a small amount of ethane, propane, butane, and it can be used in internal combustion engine. It is stored either in gas phase at a pressure of 150 to 200 atm as CNG or in liquid phase at 1 minus 62 degrees Celsius as LNG. This is a comparison chart of some alternative fuels with gasoline. In this chart, the energy content of different fuels are given in kilojoule per liter and their comparison with gasoline. As you can see, biodiesel and diesel has nearly equal energy content. According to this chart, CNG has very less energy content than other fuels. Here it is a comparison between the properties of biodiesel and diesel. The only main problem with biodiesel is its pour point. The pour point of a liquid is the temperature below which the liquid loses its flow characteristics. Biodiesel tends to be thickened and gel up at low temperature more rapidly than petroleum diesel and causes a blockage in the pipeline. Biodiesel contains very less sulfur. That is a good thing to result in reduced pollution. And here, this is graph show a comparison between the biodiesel and diesel, the emissions of carbon dioxide and nitrogen oxide at different energy loads. As a result shown here, you can see that biodiesel is much cleaner fuel than the diesel. Now further slide will be discussed by the Rahul Singh.
P-series fuel addresses three problems: the dependency on petroleum energy sources, solid waste management, affordability. That means waste that municipalities would otherwise pay to have hauled away allows the fuel selling prices to be about the same as mid-grade gasoline. It also gives urban areas control over a large portion of the generated trash without relying on burying or beneathing it to the other states. P-series are easy to use, including a FVV flexible fluid vehicle. P-series fuel is identical vehicle with gasoline. P-series fuel have several emission benefits also over gasoline and other fuels. It has been observed that the greenhouse emission emitted from P-series fuel are about 50% lower than that of gasoline. Naphtha is a term used to refer a group of volatile, flammable mixtures of liquid hydrocarbons. It can be used as a fuel because it contains a large amount of chemical energy and it is volatile. It can create about 3.14 megajoules of energy per liter. It can also use as an additive to other fuels to increase its energy content. Concluding, I would say in replacement of ongoing fuels, we can switch to P-series fuel as they are economically competitive with gasoline. Similarly, biodiesel is a direct replacement of diesel, which has nearly equal energy content than diesel, and it is renewable sources as well. Thank you.
Hello. Yes, Rahul Singh. Oh, both are students of BTech, UG first year.
Yes, yes, sir. Third semester, second year.
Okay. Second year, third semester. Okay, thank you for your attempt. You are starting attending conferences at least. It's good. Uh, my question is, people are racing towards batteries in land. We are people from land. What about the equivalent or similar diluting of fuel with some other things so that we can reduce the NOx reduction? Similar to land, is there any in marine application? This is out of my interest. I am asking this question.
So in land, you can use P-series. P-series fuel is very efficient.
Sorry, in marine application, what is going on?
In marine application, basically we use heavy fuel. The problem with the heavy fuel is its high viscosity that causes blockage in the pipeline, and also it forms sludge. And
no, we are using ethanol, 10% ethanol, 5% ethanol by diluting the fuel and
yes,
try to convert it. Likewise, what is happening in the marine fuels?
Marine fuel in some countries they are using biodiesel as a blended, like B20. In B20, 20% are biodiesel, and other 80% are diesel. And also they can use B5. In B5, 5% biofuel, and the rest are diesels.
Okay.
So they can increase the energy density.
Okay, we have standard emission norms for vehicle. Likewise, is there any emission norms for ships? This is my question. I don't know actually. In shipping industry, we are people from land. We have BS6 following now in India. Okay, is there any emission norms for the shipping industry also?
So in shipping industry, the MARPO makes the rule of the emission of any gases. Like they have make the rule to at the lowest reduction of emission of sulfur.
Okay, thank you. Next.
Okay, thank you, sir.
I think it's over.
There is a question from audience. Which fuel you suggest to replace HFO in short term and long term in maritime applications?
In my point of view, biodiesel is very good. Every fuel has its positive point of view and negative point of view. In HFO, it's its viscosity. Because of its high viscosity, it causes a problem in pumping, or it also forms sludge. So in biodiesel, we can use as a blended fuel biodiesel. In case of diesels, basically in ships, diesel engines are there. So biodiesel are very useful in that.
Answer is by Anuj Kumar.
Yes, sir.
Better you can switch on your video. There is no problem in while you are answering. Better you can switch on your video, and the answer should be based on the research or evidence. It should not be based on yourself. Okay.
No, sir. Okay, sir.
It should be based on the research and available resources.
The data available on the basis of that.
Okay. In that way, it has to be project. This is a comment only. Okay.
Okay, sir.
Okay, thank you.
Thank you, sir.
Thank you all. Thank you, participant. It was well presented. On behalf of School of Marine Engineering and Technology, I extend my heartfelt thanks to the session chair, Dr. S. Muhammad Ali, Professor, Pondicherry Engineering College, for your valuable time and suggestion. Now over to HOD for a few words.
Yeah, well, today is the second day of our two-day national level e-conference. First session is completed with all presentations. All were done well. I appreciate all the presenters. So let them start their research. As the session chair pointed out, some of them are ready to start their research. Let them launch their research work. So, and then special thanks to Professor Dr. S. Muhammad Ali. In his busy schedule, he has given a slot. I requested him for only half an hour, extended nearly about 90 minutes. Thank you, Professor, for your valuable support and guidance. We'll take your service for our IMU for research activities as well as academic activities.
Yes.
I hope
I
your
have a
university
little,
may allow.
yes, yes. I have a little bit marine experience also. Shivasami knows very well.
I'm coming to that part. One more information to the delegates and audience. He is my best friend for last three and a half decades. He is a marine engineer. He started in his career as a marine engineer, but he diverted to his area academics. Thank you very much,
Thank you.
sir. Thank
Okay,
you.
thank you.
We'll meet again. Bye.
Okay, thank you.
Okay, now we are end of the first session of second day conference. Now, after a few minutes break, we are going for keynote address. Special speaker of this keynote address is Captain V. Ramadas from Synergy Maritime Private Limited, Chennai. Will join after a couple of minutes. Thank you.
Thank you.
Thank you.
It is time for the next session. Welcome back all. With the end of the third session, the most awaited moment has come. It would be a great exaltation for me to introduce the keynote speaker of the day, Captain Ramdas Venkatarao. Captain Ramdas Venkatarao is the director of Synergy Maritime Private Limited. After completing his BSc in physics, he joined as ship cadet in 1989. He sailed on different type of vessels until getting command in 2002. He then decided to quit sailing and he joined as a manager for well-established ship management company. In 2006, he became a part of funding team of Synergy. After completing MSc in psychology in 2013 from Madras University, he is serving as external examiner, as master, and as mate with DGCP. He is presently working as the director QHSE. So with this, I'd like to invite Captain Ramdas Venkatarao to deliver keynote address. Sir, please.
Good morning, all. Thank you very much. Thanks very much for the good introduction. And respected Vice Chancellor, Dr. Malini Shankar, Director, Dr. Raju Balaji, President of IME, Shri Uday Purohit, the convener, Dr. Shivashami, and other dignitaries and the senior members of the industry, faculty, and my dear students. I would like to express my sincere gratitude to allow me to present the keynote address in this August conference on the energy, environment, and sustainability. Right from 2003, when I preferred to settle ashore, I always try to participate in various gatherings and meetings, especially where the next generation, especially the students, are involved. I visited many universities for either for the recruitment or for attending some seminars. And especially IMU, IMU is very close to my heart. I've been there quite a lot of times, including for doing some courses. And I'm happy to see that the way that has grown from a small institute to a very big university leading India in the maritime area. The topic energy, environment, and sustainability is no doubt that is indication we are talking about the future. As the students here are all going to be the pillars of the next generation. And I can also see that the presentations that are given are extremely high in quality. I was really thrilled. I was especially wanting to attend the last session where a lot of engineering topics were being discussed. And I can see that the next generation are going to tackle a lot of problems which we have not seen. And also, this is the right approach. I mean, there has to be a way by which this has to be addressed. I think the systematic research approach is the right way to address this problem. Now, kindly allow me to present a small presentation which I have made. Are you able to see my screen?
No, sir. Sir, please. You are not presenting, sir.
No?
No.
Wait a moment, please. Sorry.
So please use the present now option.
Yeah. I'm done.
Yes, sir.
Are you able to see now?
Yes, sir. Yes.
Yeah, thank you. I thought I will address a few areas, though I'm not an expert to talk about energy and environment, but I am working on few areas, especially handling many emergencies and operational problems. I thought I will take that one and then how this is usually being considered and how this is usually being handled, and then where are we exactly, so that I can project few of the problems that are there in the industry now for the students especially and the researchers to consider, and then work towards some good solutions, and then how do we move forward. I took the very recent incidents which all of you are quite aware of. I have taken 4, but I'll try to see that I'll finish quickly, but I'm not going into the complete incidents because I'm sure that all of you must have been going through that in the newspapers. The Vakashu, a Capesize bulk carrier on a voyage from Asia to South America. When passing off Mauritius, she went quite close to the land, supposed to have been more than 5 miles, but went about 2 miles, and because of which there was an grounding. And you can also note that there were really a huge quantity of oil being released, and the master and few of the crew are in real difficult time. And there is huge fines and all over for the people. And I went through the reports that has been published by the owners and the operators. Everything blaming about why did he went close, and then the reason for him to go close, and then the decision that are taken by the ship's team, and nothing beyond why they have to really go close and what is the real need for them. This is, I hope all of you are aware that in the whole thing that the vessel went close only because they couldn't get the signal and the vessel did not have internet connectivity. Now the whole seminar is being coordinated with an internet. You know, the people across the world and many in India are all online using some simple technology, but in the ship, the people who have been really moving the cargo from A to B, they not all the ships are having this type of a facility where they could connect, so they had to go close. Now, if you talk about this industry, what happened in this COVID, there were many changes. In the last COVID, if you see, they call about a new norm. Things have changed. The people, the wearing the dress, like the Levi's is saying that they have to reconsider about making the pants and the jeans. And there are also about the petrol expenses, holidays, picnics, movie halls, so many changes that have happened in the last 1 year. Examinations, colleges, courses, the way something is being conducted, so many changes. But if you see the shipping, the cargoes were moving. The cargo, because that is an essential commodity, and you need to have it. Then only the rest all activity can happen. So the ship owners were, initially we were even worried that how it is going to affect the whole industry. Of course, it affected everywhere. It is not only one part, whether it is cargo owner, ship owner, other operators, everywhere. But the way the seafarers struggled, we all know that. There were no possible sign-on, sign-off. There were extended contracts. The people at home having a problem of COVID and they couldn't come here or they couldn't leave this place. And also on top of it, there were a lot of cases with psychological illness on board the ship, and the contract really extended beyond their capability. The way they handled was really, I think it is appreciated, and do a lot organizations and companies and people work towards in resolving this issue. It is still only happening to some extent. Okay. Now I would like to bring in another incident. Whenever I talk to the friends or in any of this one, I can't miss this incident because this is a tanker called Sanchi in 2018 collided with a bulk carrier, Crystal, in the South China Sea. The vessel had 118,000 tons something about the crude oil and coming from US to Korea. But the problem is one small mistake by one of the officer on the ship when taking the action, it ended up in a collision. Once there is a collision, the containment lost. The cargo came out and it is a high vapor pressure cargo, condensate oil. So which means that it will become vaporized very quickly, and even with any spark, it can catch fire. The entire cargo caught fire, and all the 32 people in the ship were charred to death. And in fact, only 3 bodies could be even recovered post this thing. The fire was there for about 7 days, and the pollution was also huge, about 100 square kilometers. It even reached the coast of Japan. This is what they claim. So now, if you see on this incident, we are only talking about some officer not making a correct action in a collision situation. Now, in fact, I must tell in this moment that the lifeboat incidences, Many of the seafarers here would definitely agree. Lots and lots of regulations came about these lifeboats, free fall, as well as this, which has got a release mechanism. This release mechanism has been failing often. And in fact, there are studies that say that the lifeboats are killing more people than saving. I would also like to mention about one of the incidents where in a ship there was a fire, which resulted because of a small mistake made by the fourth engineer. He forgot to stop a small pump. It was just 1.1 cubic meter pump, transferring oil from a regular storage tank to the incinerator fire tank. So he forgot, and the engine room was with oil, and luckily it was timely identified and then big disaster averted. But still, ships have got a lot of conditions where one small error or with a slightest different approach can always cause an error. But why? Why always it is considered only human error? Everybody is proud to say that it is 80% human error, 90% human error. In fact, you can put everything, convert them into a human error. There is no point in analyzing human error. But I want to know that why people are always being attributed. Why the people are always called as if they made the mistakes and rest all are fine. I would like to mention about 4 popular theories. One is theory of fundamental attribution, where anytime an incident happens, it is a tendency of the human to associate or attribute it to an individual, especially if it is not you. It comes close to the locus of control, internal and the external. When an accident happens somewhere out, you call it as like it is somebody's mistake. If it happens to you, it was all because something else happening around. So I luckily got a good cartoon from Peanuts, which could explain this thing in a very simpler way. There's another theory that's a counterfactual fallacy, where the people could think that, in case if I have done this way, then this would not have happened. I mean, they go so much about what should have happened and what might have happened. All this thing, though the reality need not be the case. It's a regular tendency. It is not the one they are right or wrong. That's the reason I'm putting it under the fallacy, but it is the normal tendency of the human to consider. And the other one is the just world fallacy, where people think the one who did mistake is going to get punished. If he has not mistake, he will be able to come out of this smoothly, which need not be the case in reality. But this just world fallacy has influenced people so much that anytime somebody starts making mistake and later there is some consequence, immediately you associate everything and then say that, see, you did the mistake, see, you did this, and that is why you have ended up in this position. There is one more theory called the theory of free will, where the people think that if they do everything correct, then all should go well, which also is not proven. We know that many a time people do the things, still things go far beyond what expected. Now, should we go on human approach? I think though it has been wide talked about, many of the recent researchers don't believe. They don't think it should not be taken in the way of as a human failure. So let us think about what are the other aspects. What about the regulators? What about the rules? Are they exactly made the way something can be operated? Or is there any gap? Or is that being addressed? How the procedures and process are being made? Where it considered how the human will interact with this one? What about the machineries? It is not the output of a machinery is important, how well it is designed. And not only the machinery, also we have to look at the workplace design and arrangements. You can have an excellent generator in the ship, and if you are not having a place to work on it, it's of course no use. Same way fatigue, which is still an aspect which people really couldn't come out exactly how and when and where it occurs. External weather parameters, most of the time ignored. A ship that is floating as well as moving with multiple about 6 degrees of freedom. It is not easy for anybody to see that how it is actually going to impact the other work conditions. Commercial pressure. If I go on this topic itself, I think it will take another half an hour. I don't have to say. Ultimately, there is an expectation the vessel need to carry cargo from A to B, and lots of money involved, and you can't avoid that. But still, we have to address it. And another problem which has been widely talked about is, are these activities earlier considered to be very good or rather appreciated? There was one incident that happened in Australia, a ship that ran aground on the reef. There is a case study also that was published where it clearly stated that there were so much of workload on them. If this incident has not happened, then the entire team would have been appreciated for all the good works that they have done. So next is about the lack of effective barriers. Are the people able to identify where all the things can go wrong? Or are we unable to foresee the problems? No. I would like to come back because I see a lot of engineering stuff here, though I'm not very strong at it. But I like this formula, mechanical efficiency, where you talk about an output to input ratio. Yes, you are efficient when your output is good, no doubt, but also when the input is less. Okay? So it is not just the numerator, it's also the denominator. Or we call this as efficiency when somebody with some type of an effort which is measurable into a huge quantity of pile of load, which can be, I'm sure that the engineers here would be able to say that there is an alternate mechanism where the efficiency can be proved high by a slightly lesser effect and with minimum load. Now, the theories, I don't have to say this again. If you go by the formula, it's very clear that the efficiency is nothing but the intelligent laziness. Now, but what about safety then? So the safety doesn't work along with efficiency. Safety goes with rules, regulations, compliance, or rather we simply call it as thoroughness. If something is written, you have to do it in full. It is immaterial what is your output, but the input should be full. Okay? So there is always a clash between safety versus efficiency. In fact, this is a real interesting one scenario. Once I was coming from a car I saw on the way, my neighbor's son was breaking the tip of a lady's finger at the corner of the road. I asked him, son, what happened? Why are you doing this? He told, uncle, it's very simple, uncle. My mother is saying that whenever you buy this, you have to clear the tip. But if I do this, the shopkeeper shouts at me. So this is the best alternate I found. So now just trying to associate this. There is always, one I call it as production, where there is a lot of efficiency and some outputs are considered. And there is a lot of protection where you work towards safety, and then you are not worried about what is going to be the outcome, but the standard processes and procedures. The line in black in between, then the one that goes diagonally, is the parity zone, parity line. The companies are expected to operate somewhere keeping this line at the center. However, invariably, the high hazard industry ventures always work on the northern side, whereas this low hazard ventures operate on the southern side. Now, I just shown it like with the pictorially. This is one of the study given by James Reason in his book, Managing Organizational Accidents in 1997. He clearly says that it's a cognizance. To know where you are. The company works in, because nobody can find out exactly where are you at this moment unless you do a very, very thorough analysis of your safety data as well as with your production data. And then you can see that whenever you are moving towards the production, then there are some accidents. Whenever you go towards protection in the safety side, you see that you are going close to bankruptcy, or sometimes it's a huge loss of revenue. And then again, you move towards production, and until I don't know where you will finally stand on. But the most important, which we call it as the cognizance, that you need to be knowing where you are exactly. I have talked about this efficiency, thoroughness, production, protection, a lot of theories around. Now, can we go back and then see that all the incidents I talked about, the Wakashio or the Shanchi or other incidences in the lifeboats or in the engine room, if you see there are much more components, or just only looking at what the people did at that moment. Now, when I say all these things, I must also say at this moment, because the recent definitions that are coming up, which have been forgotten over a long period of time, or thanks to many of these researchers who are working in this model, they call accident is an unanticipated interaction of multiple failures of a complex system. This by Charles Perrow, who wrote a very detailed book on accident causation. Its name is normal accidents. Same way, this Todd Conklin, he has covered a lot of concepts of Eric Hoagland, Kolnagel and others, where he very well explains the safety is the ability to perform a work in a varying and an unpredictable work environment. So you cannot ignore in work environment, you cannot ignore a complex system, you cannot ignore many of these things when we are talking about the human who is actually doing the work. Now solution. What are we doing? That's the reason I was actually attending almost all the seminars pertaining to that. And today's morning also I attended. I saw a lot of good solutions. Now the question is that is technology a solution? If so, have the solutions always succeeded? If not, why? If yes, then how? I'm not again going much on because you all know that what happened with the ECDIS, EIS, even the mobile phone that we are talking about, we call it one of the best invention. Is it really doing good? And various alarms and trips and systems and models, the list we can talk about. But I find with my little bit of understanding, the technology alone cannot, it has to work with multiple. One is with the data, other one with the human interface. So the data-driven solutions along with the technology and the human interface has made a lot of changes. Like you see COVID-19, I believe it was really well damaged compared to the other epidemics or how it could have happened all across the world. There are now studies also that talks about the pandemic analytics. I'm sure that if you go and then see that how well the lockdowns are planned and what are the models and the social distancing, everything came by an excellent analytical models. And it all also worked that how the human would be understanding the whole concepts. Now, when you talk about the design principles, again, I have to make this reference from one of the excellent author, Eric Kolnagel, who has given very, very detailed one as to how to work on with the new designs to come in. Some important elements he brings in, whether the design principles are met, whether the architecture and the components exactly match to the way it has been expected and the way it has supposed to perform, or the models satisfy the test, or the analysis method, or is it really reliable and is it valid systems, and the mode of operation for the system, is it accepted and it is going to really work, and of course, needless to say about the structural stability and the functional stability of these models. When I think we are able to address all these elements along with the human performance and their understanding with the data, I think that we are somewhere coming to a better solution. Now, this slide I really added because I thought that I must, when people are talking about sustainability, and it's a good gathering for me to say that UN has developed some sustainability goals, 17 goals across the world, and encouraging everyone to participate in this. Something on the no poverty, zero hunger, good wealth and being, environment, and the respect for the people, a lot. And I would say that at this moment, since I am all addressing the set of seafarers and the people industry, I thought that I will say a few aspects which might help. At this moment, this is being talked about a need of the hour. The working with the international community. We all are going to work. I mean, I'm talking about the students who are here is going to work on the different nationalities. There is not going to be an Indian or a Filipino or an American or an US, or an European. It's going to be a marine fraternity or a community. You need to have a lot of respect for the gender, the religion, their culture, the race, the position in which they are serving. Invariably, we all carry some of our learnings. We might have to sometime completely undo that, unlearn, and then do a good learning of this. And we must consider a lot of comforts for the people who have whether physically or mentally challenged in place of an workplace concept. And the body shaming is nowhere now considered as an accepted model. And the respect for the people who are actually different and who are not fitting in the system is another aspect which I want you guys to always think about. And the place where you are working is to be a safe space. It is not dust, it's only for you. The place should be definitely free of harassment, discrimination, and bullying. Of course, the industry is working a lot towards it to make this better. But I want everybody, especially the next generation who are getting in, keep this message with you. What I talked about is on the technology, on the human interface, on the data systems, and the sustainability goals. This is what I thought that I can communicate with you all. And thank you very much for this opportunity. I think that I'm within time, and thanks so much.
Thank you, sir. On behalf of SMET, I would like to extend a heartfelt thank you for your earnest address. I also thank you to make this event a memorable one with your gracious presence. Time has come to begin our fourth and final session of this two-day conference. It is my
Yeah,
privilege-
one second. Yeah. Thank you, Captain Ramdas, for your valuable speech as a keynote address speaker. You have covered all the areas, not only pertaining to shipping industry. You covered everywhere. So very interesting and wonderful speech. I believe all were really well taken. Your points. You started with the root cause of all the problems with the questions and solutions. So I thank, on behalf of Indian Maritime University and my own behalf, I thank for your wonderful keynote address speech. Thank you, Captain.
Thank you, sir. Thanks for that.
Thank
you.
Time has come to begin our fourth and final session of this two-day e-conference. It is my privilege to introduce the session chair of this session, Shri Pawan Kapoor. Mr. Kapoor has vast and varied working experience of over 40 years in maritime industry. He is the founder and head of ISF Group. He is former head of International Maritime Training Center, CEO of Tolani Maritime Institute, certified trainer, and a lead auditor of ISO systems. Through various programs, he has trained 2,500 delegates till date. So, I am happy to invite Shri Pawan Kapoor to address us and start our final session. Sir, please.
Thank you very much for the kind introduction. I hope you all can hear me well. At the outset, I would like to thank the Indian Maritime University, Dr. Malini Shankar, Dr. Balaji, Dr. Sivasamy, all the panelists, delegates, and the students for giving me the opportunity to be with you today and share this last session on a very topical subject of sustainability. When we talk about sustainability, another term which comes to our mind is of survivability. But the two terms are entirely different. And sustainability is one term which is becoming more and more popular, especially ever since the United Nations set the Sustainable Development Goals way back in 2015. Various industries are now following the same goals which have been set by the United Nations. And what they have set actually is something that we all as human beings, as residents of this planet, are feeling every day. While we may get caught in our own work, in our businesses, somewhere at the back of the mind, this thought keeps coming back that, are we doing things right? Are we doing things in a manner which will ensure sustainability for all of us? And that's why sustainability as a term, as a subject, it cannot be part. It has to be whole. We can't expect a part of the universe being sustainable and rest not being so. So it is almost like being in a win-win situation. So without taking much time, I would now like to begin the session. We have 7 papers in this session here, and a fairly variety of subjects that I can see here. We are talking about the information technology. We are talking about certain materials. We are talking about fuels, and we're talking about recycling waste. So I will request the administrators to please begin the process, where we can request the speakers to come one by one. All I would like to request the speakers is to please limit your time of presentation to maximum 5 to 7 minutes. In fact, you can just give a gist of what you are talking about, and let there be more time available for questions coming up from the audience for you to clarify, the doubts. So with that, once more, thank you all very much, and let's begin the session. Over to the administration.
Yes, sir. Thank you, sir, for your kind words. And with this, I would like to Shri Dr. Soumya Mukherjee for the first presentation.
Okay, thank you.
Would you need some assistance, Mr. Mukherjee?
I think it is not getting shared. My slide is not getting shared.
If you are using, laptop?
Using Google Meet?
Yes, I am using the laptop.
So
yeah, now it's presented, sir. Yeah.
Seems to be coming on. Yeah.
Is my PPT is coming?
No. Initially it was coming, now again. So you try again. You stop present. Again, you just do the same. So that we will.
Is it visible?
No, not yet, Mr. Mukherjee.
Okay. Is it visible now?
Yes, it seems to be coming on. That's right. You can now put it in presentation mode. Yeah.
Okay, thank you all. Good morning and good noon to everyone present in this e-audience. So today my talk will be a little bit different. I am actually a person of metallurgical engineering or materials engineering. So my talk is based on development of spinel, which is done through some combustion route and its characterization, a potential material for abrasion and chemical resistance for marine structures. Now, before just moving to the system, it's actually basically a complex structure. It's a group of oxides, a complex oxides, and where the oxygen anions are having some FCC base. Generally, we represent this group of minerals with the help of formula, which is represented as AB2O4, where A is actually divalent metal ions, which could be magnesium, iron, nickel, manganese, or zinc, and B is actually trivalent metal cations, that is aluminum, iron, chromium. And these compounds are actually very versatile in nature, with various applications in the field of structural to catalyst to corrosion resistance and so many things. Industrially, actually, they are produced by solid state mechanism, that is high temperature processing. But if we go for lab process, it is generally restricted to sol gel, co-precipitation, PVD, and so many things. Various examples are there. It could be ferrites material, it could be aluminates, zinc ferrites, and so many things. Now, in our present case, we are focusing on magnesium aluminate spinel. It is one of the group of spinel. Actually, there are almost 500, 600 compounds of spinel. Now, this is the thermodynamics of the phase diagram of the spinel, which indicates its formation. If we look at the diagram, two ends are represent magnesium and alumina, and actually at 72 weight% composition of alumina, theoretically, we are getting the spinel part. Now, this is the brief materials method. This is a chemical route process The precursors are the nitrate, aluminum nitrate, magnesium nitrate, along with citric acids. We have varied the composition little bit. Now, with the help of an oven, we have dried it at 80 degree to get the gel. Now, before moving to any heat treatment process for the final product, we have undergone one thermal analysis to have the logic behind the heat treatment. Now, that thermal analysis give us the idea of the transition periods of the heat treatment, and after heat treatment we have undergo phase analysis, because before putting the compound in use, we have to be very sure whether how the compound is actually, whether the compound what we want to make is actually that compound or not. So that these characterizations have been carried out, the phase analysis, some spectral analysis, and morphology, from where we can conclude whether it is fit for corrosion or abrasion resistance. Now, the result discussion, the first part is the thermal analysis. Now, from the thermal analysis, we are indicating the crystallization zone, that is the heat treatment zone. Now, the weight losses are indicated up to 300 and above 500, but the weight loss above 500 is quite flat in nature, which indicates our heat treatment zone. And initial weight losses are mainly due to the hygroscopic moistures, due to the crystal structures, the nitrate salts, and formation of gamma alumina, which is actually a low compound. And at higher temperature, this formation gets transformed to spinal. So that's why we are getting flat zones. Now, these are some phase analysis. We have carried out the heat treatment from 600 to 800. Some data are given, that is for 650 and 800. For 650, we carried the phase analysis, that is spinal. But the problem is that little bit amorphous structure, it is not fully crystalline. But in 800 degree, we are getting much more crystalline due to sharp peaks of the XRD. And even in 650, with molar ratio of the citric acids, we have varied the molar ratio from 1.25 to 1.75. It has been indicated that 1.5 molar ratio at 800 degrees centigrade of ambient temperature with 5 hours give us much more better compound in terms of crystallinity and also in terms of purity. And the crystalline size have been observed to be around 25 nanometer. Now, this is the FTS spectra. The FTS spectrals are essential in order to validate the chemical composition, because XRD will give us the phase analysis, the phase, what phase we are on, whether it is in part of spinal or not. But the phase analysis along with the chemical analysis will confirm the real nature of the compound. Now, from the FTS spectral analysis, we are getting the required bonds, that is the magnesium oxide bonds, aluminum oxide bonds, or aluminum magnesium bond, which are very much essential for the formation of the spinal compounds. So this FTS supports the XRD data. Now, this is the same morphology. Without morphology, we cannot apply any material for any application. Now, if we have a close look at the same analysis, it is a very dense structure. The dense structure indicates some set of mechanical inherity of the structure. And since it is dense, which is devoid of porosity, so there will be very little chances of any chemical ingression within the structure. So if we apply already as a coat or any structure, so it will act as an impermeable membrane. As a result, it will enhance the corrosion resistance. The microstructure, from the microstructure, we are getting the individual particles to be in the range in some micrometer, that is 0.3 micrometer to highest to 1 micrometer. Now, this is the EDAX analysis, from where we are getting the magnesium, oxygen, aluminum presence, and it supports our FT analysis. So in a very short, we have synthesized in a very simple chemistry route the spinal compounds, and XRD analysis have shown the successful phase formation, which is where the heat range has been confirmed from the thermal analysis, where the thermal analysis indicates the crystallization within 500 to 700, but we have deliberately increased the temperature to have a proper phase formation. But this temperature is much lower than solid state century, which is around 1500 degrees centigrade. FTN analysis indicate our metal oxygen coordination, that is the chemistry part, where we are getting all these analysis, while morphology is supported from the same, where we are getting a very dense structure, agglomerated chunk structure. And this dense structure gives an indication that it is a very good for good mechanical properties and also corrosion resistance. Thank you.
Right. Thank you so much, Mr. Mukherjee. Very interesting presentation and a very new concept to me personally. I would just like to ask you a few questions here. When you say spinal you're looking at it more like a coating on a marine structure, right?
Yes, yes. Obviously.
Okay. So will it be kind of be there as part of the paints that we apply, you think, in the marine structure? Or
Various ways, sir. It could be in the form of paints where we can add the ceramic material in the form of some emulsion in the standard structure, or it could be carried out with the help of some coating techniques, where industrial coating techniques like PVD. Though it's a little bit complex, but it could be done now with advance of these all techniques. It is already done. Though it is applicable in aerospace like in H2O techniques, but it could be extended since marine structures are very much versatile in nature, and there we ended one structure for 50 years goal line, so it could be useful.
Okay. And how's the cost effectiveness of Spinal? I believe it's an expensive.
It's not so expensive. It is already in the RN steel making structure in industry, sir. And Spinal coatings are already in defense and already there. So it's not a very new concept actually. So we are extending one concept from one industry to another. And that is the new motto of today's world. Suppose we are extending granulate for composition of pharmacy to powder metallurgy. So that's the mixing up of the concepts, interdisciplinary approach.
And the production of Spinal in a finished form, let's say for applying in marine structures, what kind of carbon footprint would that leave,
So that's why we have carried out the chemical load. So the temperature is 600 to 700, 800. So the carbon footprint automatically will get reduced. But in industry, for say cement industry where we are producing the refractory, that footprint is very large because we are utilizing solid state center that's around 1500 degree. So temperature is reduced and the roots are not very detrimental. We can utilize special precursors and we can enlarge the material with the help of surface enhancements.
Okay. Thanks a lot for the inputs. I'm sure the industry would be looking at it. Any questions from the audience? Please, you may unmute yourself and ask Mr. Mukherjee. If there are no questions, in that case, may I request, thank you very much, Mr. Mukherjee, for your lovely presentation. And maybe we can move on to the next presenter now.
Moving on to the next presentation, please welcome Srinanda Kumar SK for his paper about climate forcing and air pollution over South Africa.
Presentation add now.
Srinanda Kumar SK. Yeah.
Hello.
Yes, Mr. Nandakumar, welcome. And your presentation is coming very clear, so you can please proceed with that.
Sure. Thank you for that. Well, a very good afternoon to everyone who are gathered here. First of all, it's a proud privilege for me with a lot of mariners and maritime industry peoples these days. Let's go on the topic. Actually, I'm going to give a little elaboration about what is the climate things and how it is dealing with the coastal environment which we are going to deal. And we are, being a mariner, we are always sailing in sea. But we are sailing in sea, that's only. But we don't know what is the environment which we are facing. And we know that our ship is neat and clean, how we are keeping. The same thing is not happened in the land where we stay. So in order to deal the things, we have to know the environment status of our country. And just I will give a small things that nowadays youth are having an interest to go for US, UK, like the things. The main thing is that my thought I will just explain. They're just thinking not of for the salary or anything. First of all, they are thinking is going for the cleanliness. This cleanliness only creating a lot of impact for us in a way of attraction. This attraction may be keen us to move forward from
our native land to some other land, and we are working for that. So I'm not telling this is a right statement. It is also a one statement. It is dealing. So in order to overcome everything, we have to keep our environment neat and clean. That is my code. I'm starting my things. First, we'll tell the headings. I'm telling about climate forcing. What is climate forcing? And why this word climate forcing I'm using? Climate means a long time of change in the environment, which is going to give a change in the future. It's just an alert. How whether it will increase in case of temperature, or it will in case of rainfall, or how the environment will face a hazard in future. That only the term climates. Forcing means how that stakeholder or human population which is impacting that places, and that they making the places either damaged or in a good condition, that the sentence stating you as forcing. And coastal region, we everyone know the region which is between the land and this, the interaction of the region which is between land and sea. This is the region of coastal region. And one more big things, marine aerosols. First of all, we have to know what is aerosols. Aerosols means, before that I will tell what is air quality and what is the air quality means. We know everyone, we are always asking what we are breathing, what we are living, the place should be neat and clean. So the statement air quality telling you the place you are living, it should be a clean and hygienic air. So the air quality is having a numerous numbers from a range of 0 to 50, from a range of 50 to 100, from the range of 100 to 200. It having a ranges. The range within a limit, and it has the standards. If the limits and standard is meeting your recruitment and that level is perfect, then you are attaining the perfect environment where you are staying. So like I'm telling, if the range is from 0 to 50, the area you are living is health and hygienic environment. If the range is from 50 to 100, the area where we are living is having little impact. If it is having 100 to 200, then the area having hazards of air parameters is little more. If it is exceeding 200, then the area where you are living will reduce your lifespan. That is the statement. So in order to keep your environment clean, so you have to maintain air quality and the parameters meet. So let me see what research I did for these things. I will give a small introductions. Nowadays, people are doing the air quality analysis in the land structures only. The difference between others and this research is, this is the first research in our country which we are dealing the air quality in the coastal region. You can ask why you people's dealing the region of coastal. When you are dealing land, there is only one boundary layer of interface, depends on the atmosphere. But when we are dealing that coastal region, there is a two boundary layer. One is the air layer and another is water layer. So the interaction between both things you have to think in a way, and this competition and merging is having numerous process, and it is not easy to do. So we took this topic, not for these things. It is a new research, and it will affect the peoples who is in coastal region, and that peoples are almost mariners, and the stakeholders who is in fishing and other things. So just I will tell that air quality how means. Then in this air quality, there are lot of parameters like particulate matter and sulfur dioxide, nitrous oxide, ozone, VOCs. VOCs have 6 types like benzene, toluene, 1,3 tetrabenzyl, like that. Numerous things are there. This we took only one part of parameters, that is particulate matter. In this particulate matter, there are 2 parameters. One is PM10 and another is 2.5. Nowadays, there is lot of research going on, and the size of PM, which is having less than 2.5. Let us take PM1. Why I am telling? We are thinking when we are reducing the concentration of the particulate matter, it is reducing the effect on environment like the government is thinking. But the statement what government is thinking is not perfectly right, because the effect of size of the particulate matter is affecting the health of the body. If the particulate matter size is large, the affecting range of the health of a human is less. If the size is reduced, the effect range on the body is more. So when we are using the diesel emission, the emission factors and the emission particulates coming outside from the vehicles are that size is more. When we are using petrol particles, that size is little less compared to diesel. But when we are using CNG, the size is comparatively much and much smaller than the particulate which is emitting from diesel. So when we are using CNG, the hazard for human and the health impact for the human is more. But nowadays everywhere we are replacing CNG autos and vehicles and everything. So this thing we have to keep in consideration. Is just a general information.
Mr. Nandkumar, if I may please come in here, we will need to maintain time. You already about 7 minutes into your presentation. Kindly, if you could focus on the key points so that we have some time for interaction also. Okay, thank you.
Sure, just I will move first.
Yeah,
okay.
Yeah.
Just everyone please go through the picture which I'm showing in PPT. It is the picture of the whole world which showing the maritime trade routes and how it is affecting the peoples in the continents. When we are seeing the picture, the continental boundaries of India and China is affected more because of maritime route is more, and the emissions of the particle from the ships is more in this region. It is affecting both health of the region and climate of the region. From this picture, we are elaborating that things. And from that picture, I am telling that objectives of port emission and the climate in this region was entirely changing, and it is affecting more. So what we did, we stayed in a research vessel of South India coast. Its name is Sagar Manjusha, and we kept that analyzers around above the deck of the ships, and we analyzed the air qualities around the coastal stretch. And we use the method to identify these things. We use 3 methods. One is direct collection, another is port data of emission collection, and another is coastal region, how that emission is impacting with respect to satellite data. And we use one more things, that is automatic identification of ships. Just now our sir elaborated these things. From that we collaborated with the IMD data, and we find out the weather prediction for the nearby region. From that we observe the nearby coastal region. These are the surveys region which we took by the Sagar Manjusha ships, and this is the method how we did. This is the nearby Pondicherry coastal stretch where we did this. And finally, from that, we got an idea when the ship is in anchor and when it is in maneuver and when it is in sailing, the emission range was entirely changing. And it is depends on not only that emission particulates emitted from the, it is also depends on the wind speed, ship direction, and ship speed which we are sailing. And here we are facing the problem. Always we are that research we are finding means we are always taking the thermodynamics as a dry bulb temperature. But when we are dealing in coastal region, we have to consider the wet bulb temperature. Because of the wetness of the particle, that pollution which is carried out by air was getting wetted, and it is becoming a colloidal particle. That colloidal particles only we are elaborating as aerosol. So what we did, concentration of the aerosol from the 2007 to 2012 we did, and finally we came to know there is a reduction in the particulate concentration. And from that we concluded that coastal range of which are 4 nautical miles are having the impact of the particulate in that region is little less. And when we are comparing the PM10 range from the port is little more, around 80%. But that emissions of a particular the ship routes are little more. So the routes of the ships, they are not following the proper norms which is followed by IMD. That only we finding that as a conclusion. So after that coastal stretch of 4 nautical miles or so, ships should follow the proper rules followed by IMO. This we made a model scenario and we find out the emissions. This is my presentation. Thank you.
Thank you, Mr. Mr. Nandakumar. Thank you very much for an interesting presentation. I'll leave it to the audience. Would you have any questions, please? Feel free to ask Mr. Nandakumar.
I have a question. This is Sivakonda from Indian Maritime University.
Yes.
To the lecture. I was wondering, how do you segregate the effect of the ship itself on which you are measuring the ambient air quality, sir?
Actually, we are finding in the way of emissions in 3 ways. One is through the emission factors emitted by ships, and another we are finding the whole satellite area of emissions, how it is coming. So the whole area emission I am taking and I am neglecting that emission which is did by ships. So I am finding that emission in the places. This way we are finding.
No, not that. When you measure ambient air quality, how do you make sure that your own ship doesn't contaminate your observation?
Yes, surely it is contaminating. Actually, I told right 3 ways. One is satellite and another is whole that's our ship emission factor that is contributing that emission into particular maritime stretches. Hello?
Yeah, okay. Yeah, please go ahead.
And one more way I will say this, from this 3 ways, this whole emission in the area is getting contributed. So we are finding now we are not missing a single term in these things.
I see. Okay.
May I ask you one question?
Yes, Mr. Kuti, please ask.
In the map you have shown, I saw that the red color is, of course, whole of India is more or less covered with that. But north region, the Himalayan area and all, also is appearing in that in the red color. So how the emission, from where this emission?
Yes, that's very good question, Professor. Actually, I will tell this answer. See, this emissions is not only depends on that vehicles. And I told one more thing, it is depends on the wind pattern and wind speed, which is in the continental stretch, how it is facing. So if I am standing here and I am doing some smoking, sometime I won't get an impact of the smoking. The person who is standing exactly 90 degree to me or 90 or 180 to me, that person will get more impact compared with me. Hello?
Oh yeah, okay.
Okay. So in this way, if you are finding, sometimes you can tell here ships is coming more. This country, there is now having lot of emissions and air quality parameters in this country is less. It is not like that. It depends on the stretch of the region and what is the climate in that region is fixed. It is the main thing.
Okay, but is there any tendency for this to worsen when the climate is colder climate or hotter climate?
Can you please repeat? I am not getting it properly. What more parameter? Please, can you please repeat?
No, the temperature, atmospheric temperature, how does it, colder region, the effect is more or less?
Sure. Actually, colder region it is more, but it is not showing in a air quality parameters. Because I told, in colder region, the particle will get stick with the colder small space, then it will become an aerosol and it will come and stick in a solid particles nearby you. So you can't able to find that is the air quality. It will come as a solid dust. We will tell mist, fog, smudge. It will come in that pattern. So it won't come in a air quality pattern.
Okay, thank you.
Right, Mr. Nandakumar, thank you so much for your presentation.
Okay.
Yeah, I think we can move on to the next presentation, please.
Yes, heading towards the next paper, we have Captain Sri Mihir Chandra with enhancing cybersecurity awareness in maritime industry.
Yeah. Good afternoon. This is Captain May Chandra, faculty IMU, and my greetings to all the panelists, Honorable Vice Chancellor, Dr. Sivakulandar, Director Dr. Raju Balaji, and the convener Dr. Sibswamy, and also especially to my teacher during my master's and on the chair, Mr. Pawan Kapoor, 1992.
Okay.
92, 93 there, and it's an opportunity of after many years
Yeah, Mihir.
to be with you.
Yeah, I'm not able to put a face to the name, but thank you so much for remembering me. Thank you so much. Yeah, please.
And I must inform the panelists and to the target audience also that this is not my research paper, this is not my research topic, but a sort of interest which tried to focus on this paper presentation with some of the incidents which took place in marine institutes in a couple of years back, where I had come to learn that the examination pattern of internal in the colleges and campuses are getting hacked, and the students are taking the vendors outside the campus to get hold of the papers on some ransom. And from that time, it was of sort of interest to me to crack this. That's why I said, and I submitted that this is not my research paper, but of interest, which I put up across to you. And neither am an expert in this field, as it is an ongoing process. And that's why topic is suitably named. It is enhancing awareness into this cybersecurity or the cyber world. The cyberspace word itself came in 1980. If my memory serves me well, this was due to fiction, which was there popular in 1982, and William Gibson was the author. And in the short story of Burning Chrome, this cyberspace word came first. And now it has become prominently identified with online computer networks. So cyber, virus, these are all now into our system. One virus is COVID, which is in our life. And another virus, that is vital information resource under siege for the computer networks, virus as it is, which is again in our life. And that's why this presentation, I'll take exactly 5 minutes to complete this. As I start now, if you can tell me that I'm audible and my screen is visible, it will be really obligatory from your side.
You're audible, but you are not.
You're audible. Yeah, we can't see your screen yet, Mihir. I think you have to.
I'm doing it. I'm just doing it. Sir. Doing
sure, sure. The presentation is still not visible. We can't see your presentation yet. Could you once try? Please try. Yeah.
I'll try again. think it's not coming.
You just have to click on present now and choose your entire screen, and then ensure that your presentation is available on your screen at that time.
Just like the restart, so give me 2 minutes, sir.
Yeah, in case you're facing problem, we can always have the next presenter. You can come back after, if you need more time.
Okay, if a session chair permits, we'll go to next presentation. I'll let him settle down.
Yes, Dr. Sevasamy, we can do that. Captain Meher can, in the meantime, sort out his computer issues. May I request the next presenter could be called now?
And I would like to invite Sri Hare Ram Hare with an overview of alternate fuels.
Thank you very much, Varun. A very warm and healthy good afternoon to one and all present here. My name is Hare Ram, and I am the Marine Engineering faculty at IMU Mumbai Port Campus. First of all, I take this opportunity to thank the organizers of this 2-day national level national level conference on energy, environment, and sustainable shipping. And also, I would like to thank my colleagues and senior colleagues and the faculty from my campus. And I would like to thank all the support from the IMU. My topics is alternate fuels. So now I'll be presenting my screen. Alternate fuels is a topics. It is long time we are discussing. It is not the new things, but why the relevance has come now? Why we are concentrating more focus on the alternate fuels? So idea is that there are various parameters that would compel us to think over that. So we'll see here what is the necessity, why that we are discussing now the alternate fuel. So as all of us are aware, in the future, local air pollution will be subject to tougher regulations, and shipping contributes to 3% of the world's total man-made carbon emissions. And the most important reason is the this IMO sulfur cap, which has already in place, which is effective from 1st January 2022, where IMO has made a cap on the sulfur to control the SOx and NOx to have a clean environment. But this alternate fuels has various challenges also. Switching over is not so easy. So what could be the challenges we are looking for that? So first of all, we see that reducing emissions to air and introducing new propulsion technologies are key challenges for the worldwide transport, including shipping. And then further it will again depends upon the availability, what are the fuels are available and what are the solutions we have. So all these alternate fuels have some sort of benefits also and some sort of challenges also. So being a short time, we'll just focus on the main features which would like to highlight here in this August gathering in front of learned panels. So what are the available alternate fuels if you think in the terms of shipping especially? So you see that LNG, LPG, methanol, biofuels, and hydrogen. And also we have the batteries, which is the new emerging technologies, fuel cell system, and wind assisted propulsions. These are the available options we have, especially for the shipping. Then which will be the more suitable or most suitable, that will again depend upon our technical parameters and limitations, especially the availability of sufficient production and distribution facilities, especially for the shipping. If you think it will be a bunkering infrastructure. So if you think of IMO 2020 low sulfur standards, then we are sure that the conventional oil-based ship fuels will drop, the consumption of this oil-based ship fuels will be dropped, and the share of alternate fuel will grow. This is a sure short thing. Because 2020 sulfur cap has given a limitations of sulfur fuels to have 0.5% worldwide, and further they have the ambition to reduce the greenhouse gas emission to 50% by 2050. So based upon all these available alternate fuels, LNG is considered to be the most promising alternate fuel. So in the slides we'll see due to these reasons, important reasons why this LNG have more benefits in terms of shipping to become an alternate fuels. So first of all, LNG already being used in the shipping since 2000, but it is basically on the short sea shipping level, especially in the North Sea area, Norway and all that Scandinavian countries. But same can be applied to a viable option for the deep shipping also. Only thing that we have to develop a adequate bunkering infrastructure so that this LNG could be available globally. Biofuels, methanol, LPG also have a good choice, but again this availability is a question mark. Based on current technology, batteries are viewed as impractical because we see that the current technology of the battery, it need much more space. So this, in the present scenario, this cannot be an alternate option, especially for the main propulsion engine, where we are talking about the main engine. Nuclear fuel also is technically feasible, especially for the large vessels, but there are political, societal and regulatory barriers. So due to this, we will not be able to use this nuclear also. Fuel cell system, this all under development. Maybe future we have a good prospect in this one, but right now this is all under development. Also it will take some time to reach a degree of maturity, and which could substitute the main engines. Then next, wind assisted propulsion. Although it is not a new technology, but again it will require some more development so that it could be useful for the modern vessels. Once you talk about emissions, air pollution, so first of all we'll see that what are the carbon dioxide emissions with these fuels, because greenhouse gas emissions are measured as CO2 equivalent emissions, and of all these fossil fuels, LNG produces the lowest CO2 emissions. However, the release of unburnt methane, also we call it as methane slip, that is a challenge in the LNG. This is the challenge, that because sometimes maybe you have unburnt methane, and that could slip to the air. So that could create an harm for the greenhouse gas. So that is the challenge here for LNG. And some data shows that, especially engine makers say that tank to propeller CO2 equivalent emissions of pure gas engine, if you take example, especially LNG, so they have the 10 to 20% lesser emission of, if you compare to HFO, diesel, MGO, whatever you are burning, right? So the switch over of this entire global fleet of to LNG is possible today. Only, as I said in the earlier, we have two challenges. One is the methane slip that could be tackled, and second was the availability or a bunker facility all over the world. So these two is the major things only with the LNG. Otherwise, this is the time that we could change our complete fleet and important point is also that LNG is plenty available in this gas market. So with this one, I would like to conclude the main features regarding the alternate fuels, especially in the terms of LNG. So as earlier I have already spoken that LNG, LPG, methanol, biofuel, hydrogen, all these are the important and have potential to become an alternate fuel. But again, my preference will be LNG because of the other reasons we have already discussed. So LNG also created overcomes the hurdles related to international legislation, because before becoming a fuel, it has to pass through all the international regulations. So IGS code has already in existence, and for methanol and biofuels, still the process is there. It has not come into the domain. Also, to promote this kind of alternate fuels without taxation or subsidies, it will not be easy to compete with the price with the conventional fossil fuel, especially HFO and all. LPG, LNG are the only fossil fuels which is capable of achieving a CO2 reduction as target set by IMO for 50% reduction by 2050. So this is the most important things. And most important is also regarding to SOx emission is that LNG does not produce any SOx emissions. Further, we will go on that same. The LNG price is competitive with the MGO. In that range it is there, but directly we cannot compete with the price of the HFO. And NOx emissions for LNG are lower than that of MGO or HFO. Plus the other emissions like hydrocarbon, carbon monoxide, formaldehyde from gas engines are low and can be mitigated by exhaust gas after treatment if necessary. Now we are talking about the IMO Tier 3 NOx limit. So this LNG comply with the IMO Tier 3 NOx limit without any compulsion to the exhaust gas treatment. Like other HFO and all, we are using the scrubber, exhaust gas scrubber now. So here no need. Already they have the limit within that Tier 3 NOx. LPG is the negative part, is a little expensive than the LNG. That's why again LNG will be preferred over the LPG. And LPG also have one disadvantage, that LPG related to that density, LPG vapors which is heavier than air. So what is happening? So we have to have leak detectors and a special ventilation system for that kind of fuel to be burned. These are the following valuable references I have used to make presentation and to go through the literature survey for these alternate fuels. And with this, I'd like to complete my presentation. Thank you very much for listening patiently. And now I welcome any kind of question from the audience. Thank you.
Thank you, Mr. Hariram, for the very topical subject, which is a very hot subject today.
Yes,
we
sir.
all are talking about the alternate fuels, and something needs to be done quickly about it. You mentioned about issues related to availability of LNG, bunkering facility.
Right, sir. Right, sir.
Yeah. Have you delved into this further to see what is being done globally about making it available?
Yes, sir. Yes, sir. Like recently, the Singapore, they are developing the big bunker facility for this LNG. Similar way, other ports also we are getting information that they are just developing, because one important point is that LNG we have to store it minus 162 degrees Celsius.
Right.
So to have that kind of infrastructure, we need to have a more investment. This is the obstruction. That's why everywhere this is not easily that bunker facility is coming up. But definitely the bunker house like Singapore, and this is a good news that they are coming up with this big LNG facility nearby there. That's the future we are thinking that they are going to take over on that.
Right. Right. Okay. Thanks. Any other questions from audience, please, for Mr. Hariram? Yes. Yes, Mr. Kuti, please.
Yeah, may I? You mentioned about the
Yes, sir.
battery. Now, yeah. Exactly, because I didn't hear anything about solar power. Solar power also requires battery, of course, but I don't know about ocean-going vessels, how possible, feasible it is. But I can tell you in Kerala we have a passenger boat, 50 passenger capacity boat, fully powered by solar energy.
Yes, sir. Yes, sir. Yes, sir. Understand your question, sir. I am aware that in Cochin they have already developed one boat, and we have all this picture, and we have already data that in 1 year they have saved about 75 and all this 75 lakhs by using the solar. So just only ease of convenience. If you talk about the merchant shipping, which is roaming whole over the world, so that space which they have used in that boat in the Cochin, they have made that model. There is really a nice initiative, but ease of convenience of using that bunker and fuel, and depending upon the charterers and the CP roaming worldwide. So I prefer with this one only, but of course there is a future scope in solar. We cannot deny that, sir.
Thank you.
Thank you, sir.
Any other questions, please?
Yes, sir. There is one question from Mr. Prabhu. How about ammonia?
Ammonia, madam, really could be, but ammonia basically a toxic gas. So being a marine engineer, chief engineer, I have sailed with so many ammonia gas ship also. So practically, if you say that is a toxic gas, so this cannot be a replacement for other gases like LNG and LPG, which I am supporting.
Okay. Right. If there are no other questions, then perhaps we can move on to the next presenter. Mr. Hariram, thank you so much for your presentation.
Thank you very much, sir. Thank you.
Sir.
Okay.
He is ready.
Yeah, Captain Mihir, are you ready?
Yes, sir.
Yes.
Yeah.
May I just try, sir? I have sent the PPT to that side across also.
Yes, sir.
Yeah, good afternoon, sir. Thank you very much, Dr. Thangalakshmi, madam. I sent across to you the PPT in the interim period when my younger brother Hariram was presenting, and destiny ordained it that the younger brothers would present first. So, good, Hariram, you presented it first. This is a presentation, as I spoke right now, that it is for enhancing cybersecurity awareness in marine industry. And why it triggered it, that also I said in those few minutes. Next slide, please. The cybersecurity is a combination of stakeholders, and the stakeholders, what the policy they want to make, and the stakeholders here may be the students, maybe the universities, maybe the companies, maybe the manning agencies. And as we recollect that the various processes involved and the technologies are also involved in this cybersecurity requirement to be foolproof. And as my other slide will be showing it, that even IMO is seized with the matter. Why it is important? It is because of the growing use of big data, the data in the commercial shipping and logistics, blockchain coming into commercial shipping and logistics, end-to-end encryptions, IoT, and also last-end connectivity as far as the logistic and other trading rules are in effect. And most of it is connected with automation. And when we talk of this word automation, autonomous ships are already on the blocks. So that makes knowledge about the cybersecurity to be more focused. And on average, hackers are attacking around 2,244 times a day. And this research is by University of Maryland. And the scope of this paper is to establish guidelines for operators on how to assess their ship's operation. That means IT and OT, and put in place necessary procedures and actions to maintain the security of cyber systems for marine industry in particular. And I have a data for you to share with. And this research has been done in the University of Denmark in 2018. And that makes it that cyber threat is real. It shows that according to 2018 crew connectivity survey, 6,000 crew members were there and only 50% had received any form of cybersecurity training. And 20% of the seafarers have identified this gap as they feel that cybersecurity training is missing on board. This survey also highlighted that 60% of the seafarers want more training on cyber resilience and cybersecurity management, and 49% admitted that they are unaware of their employer's cyber policies. Most of the crew, that is around 41%, were of the opinion that responsibility for cybersecurity lies only with the captain of the ship. This survey revealed that 47% of seafarers have sailed on a vessel that had become a target of cyber attack, and 85% of the attacked vessels crew had not received cyber training at all. So this is alarming. And that was the new danger. And as we talk in the last slide about the new possibilities, autonomous ships and the vulnerability are such that Internet of Things are so much involved as per this slide that if, God forbid, we were talking about the human errors as Captain Ramdas had highlighted in the previous presentation and keynote address, human error is there. But human error, if it becomes a host or human becomes a host of a target or non-target attacks by somebody sitting ashore, then this human error is getting quantified because the machine is learning to create errors in our system. And that is going to be a nightmare for sailing on the autonomous ships, because all of a sudden all ships will not become autonomous. They will be remaining semi-autonomous, autonomous and non-autonomous ships as well. And then autonomous ships can become as a host for any malware or ransomware attacks, which can lead to this becoming one of the floating hazards out at sea. Next slide, please. Types of cyber attack. As far as the computer networking is concerned, there are basically three types of viruses which can attack. They are macroviruses, boot record infectors, and file infectors. Suddenly I'm presenting to you and suddenly something pops up on my screen that if you do not pay this much amount, you will not be able to get any data. Can you think of that scenario when I'm presenting or doing some litigation issues or some negotiation happening and my whole system is blocked for days together? And it happened with most clients as well. So types of cyber attacks are phishing, waterholing, ransomware, which most cannot forget ever, and scanning. These are few types of cyber attacks which are prominent for ships. And in a targeted attack, your organization is singled out because the attacker has a specific interest in your business. Like for the Mosquare, there were vendors who had the specific interest in data which Musk can take out, has been paid to target you. So we are aware of the white hat hackers and the black hat hackers as well, who can come into your system and earn in the bitcoins for their own benefits. So it's a big sort of a business which can with the autonomous ships and autonomy as well, because as we are very prone to going towards autonomy, my only advice in this awareness drive is that autonomy should be mastered. Autonomy should not be the master. Next slide, please. Targeted attack is often more damaging than an untargeted one because it has been suited, it has been made to function against your systems and processes. Now, system of services or activities in shipping under threat, administrative and crew welfare, everybody is aware of this, and other alarm systems for the ballast water, ODMCS, I can just not feel of any pollution-related claims if my ODM-CS is hacked, and because of human error, because of the viruses, my shipboard sea chest is opened up, and there is a whole leakage all around us without us knowing about it. And also the passenger services, where the data can be malfunctioned, data can be encrypted by QR codes, quick response codes. So it's a big threat. And also, which is very close to my research topic on maritime health, where suppose a telemedic system is working on the satellite sea communications, and a doctor is giving some treatment of scanning by ultrasound for a cardiovascular disease patient, and he diagnosed something wrong because of the intervention by the hackers, or he gives some other medicine when the person is sailing on board ship in the Atlantic and Pacific. That means we are definitely giving an unknown euthanasia to a person who is trying to survive, who is trying to live life. But because of the hacker, this telemedicine system has been compromised, and a different type of diagnosis and approach has been given, which is a real threat for maritime health as well. Next slide, please. Now, stages of an attack are on the survey, delivery, and also the exploiting the vulnerability area to gain form of unauthorized access, and also for affecting carrying out activities within the system that achieve the attacker's goal. These are different types of stages, and anywhere one can just fish in there, and attacker is effectively probing our defenses for weaknesses. Next slide. Measures to guard against cyber threats. There are many. As per this slide, you can see that assessment and awareness is one of the very big tool. And as I said earlier, that the research shows that the awareness level to the crew is very low. And artificial intelligence can come to our rescue in this, which will be able to detect, identify, and respond to threats immediately 24/7 into 365. And so artificial intelligence, machine learning based security solutions are designed to work around the clock, and it can respond in milliseconds for any cyber threats. But yes, adversarial AI is also into picture, where the cyber security again can be compromised. So tech enablers of cyber security are as follows: that extending the use of security analysis, improving the performance of own security policy by removal of unnecessary data regularly, feature the extraction and selection of the data cutoff and parallel processing. We must keep the data in a parallel source, and machine learning and deep learning algorithms must be in practice for better cybersecurity. It may be a high investment at initial stages, but safety never comes cheap. I did literature review on this. Marine security professionals have different additional resources with the combined strength of artificial intelligence cybersecurity. Then Capgemini also has confirmed that 42% of the computers are hacked. The study has seen a rise in security incidences. Digital Ship newsletter and G Captain article of 2020 is also showing about Digital Container Shipping Association publication, named as DCSA for cybersecurity. And even our IMO is going to have in the next year early have a resolution on cybersecurity with respect to ship owners to have their sound system against the breach of any cyber networks. And 2017, who can forget the AP Moeller Mosque confirmed that the group was hit by a part of global cyber stack named Petya, and it costed 200 to 300 million US dollars to get released. Next. References is from IMO resolutions and Captain Bharadwaj, S. Bharadwaj, who was yesterday here on the chair, and then BIMCO and Musk lines, to name few on the slide. Next slide, please. Recent hike in cyber crimes during this corona times in the name of OLX selling a vendor, that quick resolution code intelligence of a fake identity of cyber policing is very much prevalent, and it has happened in my family member concerns, and it happened in August 2020, where the amount of a lakh was fleeced. Another case which has happened, and as per the link can be seen, and then one custom superintendent also has been duped of another 1.91 lakhs, which came in Hindustan Times. Work from home, as in Corona times, are more vulnerable as PCs are open to threat comparatively to LAN or organizational unique setups. Government of India MHA also has given advisory to take home for all netizens. If any cyber frauds, complaint must be lodged on these lines. Next slide, please. Take home points. Take care of your health and cyber health. Go for physical immunity against coronavirus and invest in, for the ship owners, for the marine industry, in cyber immunity against virus, that is vital information resources in the seas for overall well-being. Next slide, please. Thank you.
Thank you, Captain Meher. Very relevant presentation on a topic which we really cannot ignore, because if shipping, we have to sustain shipping, then, and we all are moving in this direction of more Internet of Things and artificial intelligence. So the right know-how related to cybersecurity is something that we cannot be avoided, And I guess only thing I would like to say, having been in training for so long, this should not become another course which is done by companies and institutes just for the purpose of giving a certificate to the candidates. This is something which has to be imbibed so that people think about it all throughout, That is very important. So any other questions from any audience, please?
I agree with you, sir, on this. And as Barack Obama has said recently when he was president, that certificates are not for sewing or record keeping. Certificates need that the inherent thing inside the certificate to be imbibed and to be propagated. That's the real education.
That's right, Captain Meher.
So I totally agree with you.
Yeah. Any other questions, please?
No questions, sir.
Well, there aren't any. Then let's move on to the next. I think we have two more speakers left. Am I right?
Yes, sir.
Yes,
okay,
sir.
then let's move on. Yeah, please.
Thank you very much, sir. Thank you very much, Doctor.
Thank you, Captain Meher.
Thangalakshmi, madam. Thank you very much.
Thank you, sir. Thank you.
Now I'd like to invite Sri NSC Chaitanya for the next paper presentation.
Thank you. Is my PPT visible?
It is. Yeah.
Thank you, sir. Thank you for the confirmation. A very good morning to one and all. First of all, it's a pleasure to be presenting a paper in front of this August gathering. Let me start off with my presentation on heat transfer correlations for combustion modeling for diesel engine with dual injection of water-saturated MTB solution and palm kernel biodiesel blends. So this majorly comes under your alternate fuels category. Biomass as an alternate fuel is gaining prominence for solving the problems of gathering global warming and green energy crisis. In this work, a single-cylinder diesel engine was modified to run on secondary water injection equipment, which electronically controls the precise quantity of water and methyl tertiary butyl ether. In short, it is called as MTBE additive for effective NOx control. MTBE is an organic compound with structural formula CH33COCH3, and it is highly volatile, flammable, and a colorless liquid that is sparingly soluble in water. Mainly, MTBE is used as a fuel additive to increase NOx resistance and to reduce unwanted emissions. In foreign countries, MTBE is directly mixed with gasoline. We are trying out something different. We are not directly imbibing MTBE into the engine, but we are mixing it with water, and then we are sending it into the engine. That is something new that we have done here. Okay. After that, we'll be discussing about the heat transfer models for finding out the heat transfer correlations, which are applied to study the combustion characteristics. And finally, the in-cylinder pressure variations and heat release rate are predicted using the models. Pure vegetable blends can be used in place of diesel fuel directly without any engine modifications. But the problem with this is it creates knocking and gum formation. These problems are caused due to the high viscosity of the vegetable oils. Therefore, if you want to effectively use the vegetable oils, you would need to reduce the viscosity of the vegetable oils. This reduction in viscosity is possible by three methods: transesterification, mineralization, and pyrolysis. Out of these three, mineralization consumes a lot of time as a process, and pyrolysis brings about irregular molecular breakdown. Therefore, transesterification is the best method for reducing the viscosity of the vegetable oils for possible replacement to diesel fuel in IC engines. In this work, palm kernel methyl ester was obtained from palm kernel oil by the process of transesterification using laboratory equipment. The different properties of palm kernel methyl ester were tested, and comparison was made with the diesel fuel, and a trial was made to check the compatibility with the engine for a possible usage as an alternate fuel. For analyzing the processes occurring within a cylinder of an engine, one major diagnostic thing available with the will be the measured time history of the cylinder pressure, because it gets influenced by a certain number of parameters. The first one is obviously the combustion, but along with the combustion, it also gets affected by the changes in the volume of the combustion chamber, the heat transfer to the combustion to the chamber walls, and also the mass leakage. Therefore, for critical examination of the burning process, it becomes imperative to relate each of the above to the pressure for separating the effect of combustion from the effects of volume change, heat transfer, and also the mass loss. This type of data reduction is called the heat release analysis and is based on the first law of thermodynamics. The benefits of an overall energy balance to measured pressure history are it allows for consistency check on the pressure data itself. Like if at all it is any data discrepancy is there, that we can find out by doing this sort of analysis initially. If the shape of the burning curve is unexpected, or the total energy amounted for falls of the fuel, fall short of the fuel chemical energy introduced, then the data will be at a faulty data, and this can be analyzed by doing this heat release analysis. And also, if pressure data is accurate, then other things come into picture, like other important information like your burning rates, burn times, heat transfer, gas leakage, crevice effects, etc. All these can be calculated. Various standard models are available based on which these correlations can be calculated. I'm just going to go through some of the models which we have used in our research work. Okay, the first one is a heat release model. I'm just giving the governing equation. dQCH is equal to 1 by gamma minus 1 into BDP. I think you can go through this. I'll just tell you the factors that are there. dQCH refers to the released chemical energy from the fuel. Gamma, as you all might be knowing, specific heat ratio, which is nothing but Cp by Cv. V is the volume, P is the pressure, U refers to the internal energy, R is the gas constant, T is the temperature. DMC is equal to the charge mass. Sigma HADMI refers to the enthalpy flux across the system boundary, and dQHT refers to the heat transfer to combustion chamber walls. Second model that we have used here is the crevice effect model. Crevices are small, narrow volumes connected to the combustion chamber. What happens is during compression, some of the charge flows into the crevice. From what we have discussed in the heat release model are DMCR, which refers to the mass crevice flow, and H dash, which refers to enthalpy. Okay. Next one is the engine heat transfer model. Generally, around 20 to 35% of the fuel energy is transferred to the coolant by the heat transfer process. The maximum heat transfer takes place for low load conditions. Obviously, when the load is low, the more amount of heat transfer will be taking place. Out of this total heat transfer, 50% will be the in-cylinder heat transfer and 50% will be through the exhaust port. In this research work or in this paper, we are limiting our study to only in-cylinder pressure. Therefore, the heat transfer in the exhaust port is not accounted for. The in-cylinder heat transfer. This happens by both convection as well as radiation. Majorly by convection, by movement of fluid from one thermal environment or a temperature field to another. The formula for this, the governing equation for this is Q dash HT is equal to HCA into delta T, where HC will be convective heat transfer coefficient, A is nothing but the surface area of the body in contact with the fluid, and delta T is equal to appropriate temperature difference. And this heat transfer by convection, it occurs in a direction perpendicular to the fluid surface interface. There is one more model, cylinder volume model, and this consists of the clearance volume, VC, and instantaneous displacement volume, VID. Okay. Again, the VID, that is the instantaneous displacement volume, it depends on crank angle theta, cylinder bore B, the crank radius A, the connecting rod length L, and also the pin of X of. The governing formulas are shown in the slide. I'm not going in depth into this. And finally, we have simulated using a C programming, and the formula we have used based on above all these models for calculating the net heat release rate is shown in the slide. dQCH is equal to 1 by gamma minus 1 into VDP plus gamma by gamma minus 1 plus PdV plus dQHT. There is the formula is shown there. This differential equation can be easily solved numerically for NHRR if a cylinder pressure is provided together with initial value of the heat release. So basically what we wanted to tell here is that with all these available standard models, we can do a sort of calculation to what will be the combustion process, what will be the pressures associated with it, and what it is going to be. We can simulate the total process even before going for an experimentation. So we have written a C programming for solving all these models and equations, and we have derived a certain set of values. And then we went for the experimental setup for confirmation or correlating the values that we got through this process with the experimental setup. Okay. Here in this slide, you can see the experimental setup. It consists of a DI diesel engine. It's a single cylinder DI engine. It is arranged in Engines Laboratory of Department of Marine Engineering, Andhra University, Visakhapatnam. So the engine specifications are also there in the slide. So 4-stroke single cylinder compression engine, Kirloskar make 3.7 kilowatts, and all other specifications which will be helpful for engine calculations also are mentioned there in the slide. I'm going to the next slide. Apart from the major engine setup, we have customly made, or we got it manufactured actually by some other source. Okay, we have made, or we have manufactured injection secondary electronic injection equipment, which will be injecting the water saturated with MTBE into the engine, and this injection is done at the suction end. Okay, the pressure at which it is going to do is 3 kgf per centimeter square. The injection is controlled by specially designed electronic injection equipment, and it is timed to inject after the full suction valve opening happens. As I told you previously also, MTBE is a very good anti-knocking agent, and it has a low boiling point. So due to this low boiling point, what is the role of this MTBE is that it gets, or it boils first before the fuel. Whatever is the combustion heat is there, that it absorbs, the latent heat is absorbed, and it boils first, thereby sprinkling the water and reducing the temperature inside the combustion chamber. And whenever the total temperature in the combustion chamber is reduced, thereby it reduces the formation of your NOx. So basically that was the idea which led for us to add this water plus MTBE as a secondary injection. This is automatically a graph which is drawn by the inbuilt software, the pressure versus the crank angle graph. Okay. And here for drawing this, we have assumed that the diesel consumption is around 1 kg per 1 hour at full load, and water saturated MTBE is injected in 5%, 10%, 15%, 20%, 25%, 30%, and 45%. The corresponding mass flow rates are found to be 13.88. I think you can see these values in the slide as well. 13.88, 27.77, 41.66, 55.55, 69.44, 83.33, 111.11 mg per second. And then in the graph, you can see that it is also compared with the neat diesel as well. This is the graph. And these are the input data which are given for the heat simulation models. These are the various parameters. All these things were available in the equations which I have shown you, the heat transfer models, heat release models. those parameter values which are taken, some of them are standard values like your gas constant, etc. Some of them are obtained from the engine. These values are calculated and these are given as inputs, and these values are compared with the experimental results. Okay. Finally, for this research work, we have calculated the NHRR as well as the CHRR. This is the graph showing the NHRR versus the crank angle for various percentages of water saturated with MTBE. And the next one will be showing the CHRR, that is cumulative heat release rate, okay, for various combinations of your PME plus MTBE. And finally, we want to conclude that the heat transfer models available to study the combustion characteristics are found satisfactory. That means you could almost exactly get the same values that we got in the experimentation. When we compare the experimentation values in the simulation process, we could almost get the similar values. So these heat transfer models are pretty much satisfactory, found to be satisfactory. And also water is blended with MTBE and injected into the engine cylinder by fumigation technique to provide cooler combustion, thereby reducing the NOx emissions. Basically, this is the basic idea of adding the MTBE. The heat transfer model is successful in predicting the combustion peak pressure variations with the modified engine. And also, palm kernel biodiesel blends can be justified as a suitable alternative fuel with diesel engines. These are some of the references using which we have started this research work. Research references continued. Thank you for the opportunity. Any questions?
Mr. Chaitanya, thank you so much. It was very interesting, though highly technical, but it is nice to recollect a lot of stuff that we have learned as young engineers in college. So thank you very much. Is your research still continuing, or this is the final conclusion now? And could you share?
No, sir. This is only a small part of the total research that we are doing actually.
Okay.
Because this is only a conference, I have only limited to a very small topic of the total research that is going on.
Okay, but these fuels, in comparison to the diesel, etc., certainly, I guess the outcome is clear that they are preferred. You know, they would be preferred, and with the kind of model that you're creating, it would be possible to do a lot of assessment for which you may not require to do actual experimentation. Am I right on that?
Yes, sir. Yes, sir. Yes, sir. But,
okay.
This research actually here, I didn't talk about the other emissions and other things involved in that because takes a lot of time actually. So I only limited this to the heat release models.
Right. Okay. Are there any questions from the audience, please, for Mr. Chaitanya?
Yes, sir.
Please.
How this modeling approach compared to mean value model?
Yeah, reading through this, how this modeling approach compared to mean value model to high power engines such as the marine engines. Basically, this research we have done in the marine department in Andhra University only. So I don't know how far it will be. We will be able to do it further as far as salinated water is concerned, because ultimately the salination, the salt content in the water, that plays a major role in it. But as of now, with normal water, still it is having salination also. Still, with this, I think we are getting good results as of now. But we have to see it before applying to marine. Actually, before we are applying that, we have to do much more research in that. Thank you for that.
There is one another question from Mr. Soumya Mukherjee. Is there any problem regarding corrosion of engine material?
Yeah, that is what is the thing I just told. Because whenever you are using in the marine engines, the water salt content will be more, obviously, because we are doing the testing in the laboratory. We are not using the actual sea water, but actually when it comes to the practice, there might be chances of engine corrosion, which we will be doing because this research is still going on. We will be trying to negate any such factors if at all we found in the further stage. Thank you for the questions.
Any other questions, please?
No, sir.
Okay, then I think we can move on to the next presentation.
Thank you, sir. Thank you.
Final paper. I would like to invite Shri Akshay Raj for the final paper.
Yeah, okay, thank you. Just a minute. Are the slides visible?
Yes, go on.
Yeah. Good afternoon. This is Cadet Aksharaj from BTech Marine Engineering, third year. The topic on which we are going to present the paper is recycling, challenges and effects in shipping industry. Now, we all know that energy drives everything in the world and so the shipping industry. Now, if we talk about India in particular, then it has a huge source of industrial and urban organic waste. Therefore, we have a large potential of harvesting energy from these waste, and the problems like waste disposal and conventional energy sources can be effectively resolved through this. This paper in particular analyzes the several methods of producing energy from waste. In addition, we are also going to discuss the present scenario of waste to energy, that is WTE, in our country and world. The waste disposal is a major challenge being faced by the world today. One of the best ways to overcome this problem of waste management is to adopt WTE initiatives. Now, this in turn will address another pressing issue like that of finding alternate energy resources. Now, there's a huge untapped potential in the WTE sector, and believe me, the maritime industry can be an eminent contributor in this. Now, what is the current scenario in the waste to energy sector in India? Now, if we talk about India, then India, with a population of nearly 1.38 billion, generates on an average of 450 gram per capita per day of municipal solid waste, that is MSW. As of 2017, the gross generation was nearly 134,000 tons of MSW per day, out of which about 91,000 tons was collected and only around 26,000 tons was treated. So this is quite a concern for us and we must look upon this. In India, most of the waste processing facilities are not in the working condition. In fact, a huge portion of this collected waste is lying around in open dump sites and landfills, which are posing a great environmental and health hazards. Not to mention, they have also rendered large stretches of land which are barren and are useless to use. In fact, the first large scale of MSW incinerator was built at Timarpur, New Delhi in 1987 with a capacity to process 300 tons of waste per day. But obviously, this project failed due to a number of reasons like poor waste segregation, seasonal variation in waste composition, etc. And as of now in India, only out of 14, 7 plants are working. Though the amount of energy being generated from waste in India is very nominal currently, but the future of waste to energy looks quite promising for this country. Now, if we compare to countries like Sweden and Norway, then the quality of the waste generated is very difficult from what we find in India. The calorific value of the waste generated there are quite high as compared to India, and hence in India it is quite unsuitable for burning the waste, and if we burn also, then the energy obtained is quite low. Now, this is mostly because the majority of the waste generated in India is organic waste having very high moisture content. Now, what is India's potential in the waste to energy sector? Now, if we talk about India, then the MSW generated in urban areas of India has a potential to produce approximately 500 megawatt of power, which is expected to increase further. However, to reach full potential, the authorities have to ensure that the ongoing and future projects are able to sustain. Now I would invite Gagandeep Singh to talk about the various waste to energy technologies.
So good afternoon everyone. My name is Cadet Gagandeep Singh and now we are going to discuss about the various WTE technologies. So the first method is incineration, where the waste undergoes complete combustion at temperature higher than 850 degrees Celsius, and the flue gases which are formed are used for generating steam in boilers and which can then be used for various other applications. So it is good for waste having high calorific value, but it doesn't work well with the waste having high moisture content. So the second method is gasification. So here the waste containing carbon is converted into carbon dioxide, carbon monoxide and hydrogen. And these gases which are produced is collectively called syngas and which can be used as a fuel for burning and other purposes. So it is better than incineration because of very low particulate emissions. And the third method is pyrolysis, where the carbon containing waste undergoes thermal decomposition in an oxygen deficit environment. And the pyrolysis vapors which are produced can be condensed into biofuel and can be used for various applications. Now the fourth method is landfill gas recovery. Here the organic waste undergoes anaerobic decomposition in landfills, and because of which the landfill gas is produced, which basically consists of methane and carbon dioxide, and this gas can be collected and treated to be used for various applications. Now the last method is anaerobic digestion. So here the organic waste is allowed to be broken down by microorganisms in absence of oxygen, which produces biogas and can be used in multiple applications. So now let's go to the renewable energy options and WTE on board ships. So the current focus of shipping industry is mainly on wind and solar energy. Various attempts are being made to tap wind energy, but there have been no successful prototypes yet. Solar photovoltaic cells are also being used on small ships. However, WTE is still a very less explored technology in shipping. But some companies, namely Scanship and Tecotec, have successfully developed a system that converts the carbon containing waste on ships into biofuels by methods like pyrolysis and gasification. So finally, I would like to conclude by saying that WTE is still an emerging sector in India, and because of the support from government and the MNRE, major developments can be expected in future. And also in the shipping industry, countries like Norway, who are successfully running WTE plants, are leading the way for others. And because of this, the waste which is let out in the sea by the ships can be drastically reduced and would create a more balanced ecosystem for all life forms. So that's it from our side. So thank you very much.
Thank you, Akshay. Thank you, Gagandeep. A very informative presentation. I have one question. I mean, have you made any assessment in your research work whether there would be sufficient waste which is produced on board which can be converted into fuel? Because theoretically, yes, it's possible. But from a practical perspective, you think that is a possibility?
Yes, sir, definitely, because the waste produced in ships are quite high and that are in tons. And also, if we compare it to land, then the waste we generate and we can get the energy from that and we can then transfer that energy to the ship also. So it is quite possible, sir.
I guess the vessels that you're talking about are mainly cruise vessels, passenger vessels, not the cargo ships. Am I right?
Yes, sir. Mostly the cruise vessels.
Okay. Okay. Yeah. Are there any other questions from the audience, please?
No questions, sir.
Okay. I think Mr. T. Mohan was also supposed to present. I guess he's not. His name is there in the list.
Yes, sir. He was about to present, but he's not available.
Okay. Okay.
You can conclude the session.
Right. Okay. So I would then just like to say thank you to all the presenters for wonderful presentations. Very informative and fairly diverse in nature, you know. So we, as I said earlier, we are moving from the IT sector into materials, alternate fuels, and so on and so forth. And all these actually, if they can become reality, they would definitely contribute to long-term sustainability of shipping, you know, in a big way. So with that, I would like to once more thank MU, Dr. Balaji, Dr. Malini Shankar, Dr. Sivasami, Dr. Siva Kolundu, and all the other staff members, organizers, for giving me the chance to be part of this session. We wish you all the best. Thank you very much. Thank you.
Thank you very much, sir. Thank you, all the participants. All presented very well. On behalf of School of Marine Engineering and Technology, I thank our session chair for his valuable time and suggestion. Over to HOD.
Thank you.
So all the presentations are done very well. All presenters, they have done carried out their job perfectly. All the papers are very informative. As our session chair mentioned, that the sustainable shipping, the area itself very challenging area. So work is going on about the sustainable shipping. So thank you very much. On behalf of IMU and on my own behalf, I thank our session chair for this two-day national level e-conference, day 2, session 4, Mr. Pawan Kapoor. Thank you very much. This short from our side, we have given only short notice. In the short notice, he has given his consent, and he has completed his invited only for second day, but he has spent 2 days in the national level conference, made this conference very success. Thank you very much, sir.
Thank you very much, sir. Thank you so much. Thank you.
No event, especially a digital one, can take shape without a team of enthusiastically hardworking and dedicated people. As we inch closer to the end of this e-conference, I invite Head, CTCE and Academics, Consultancy and Research, IME Chennai Campus, Dr. K.M. Shivakolandu sir, for the valedictory address.
Yeah, thank you. The conference coming to a completion. And it's really heartening to see such efforts continue to be made even during these times of restricted working conditions. And the conference is really helpful to widen our horizon, like our earlier speakers, Mr. Pawan Kapoor and HOD said. It really widens our horizon with the variety of very relevant topics in marine engineering. The spread is really large, starting from energy, environment, electrical, electronics, control, automation, mechanism. The list is quite a long one. Also, the participants come from a varied background. It's not fully cadets or it's not only fully faculty or anything. It comprises everything like students, scholars, researchers, faculty, professionals, a complete spectrum indeed. Now, the coverage is quite impressive from basics to contemporary and emerging new ideas. And the student participation is very interesting. There are some young minds given a very unfettered imagination. Even yesterday I saw one such presentation using a huge magnet to break ship movement, something like that. It's good. People are just imagining out of box solutions, and even some of these ideas sound audacious. We all know that these are the thing that needs to be encouraged as an educational organization. After all, this is a testing ground to provoke discussions, and there were discussions I have been following quite a bit. And coming to the academic research as such, you all know that there are some limitations in the academic research, even though it comes with all the rigors that go into the research. The academic excellence may be certain, but the applicability to real world condition, or rather the problem solving, may be limited, or it's not guaranteed always. Of course, it need not be if it is a fundamental research. But on the other hand, if you see the funded research, like industry-sponsored research, it always comes with some other rigid attributes like time limits, the clear-cut objective, and then the contemporary issues of the industry, and finally the scrutiny. Your work gets scrutinized by some user. That has got a lot of value added to your own progress. It will be better if the proportion of the papers presented in the national conferences do increase from the category of funded research rather than purely academic pursuit. That will really add more value. And I believe there are research funds that are generated by industry at international level, like IMRF, or International Maritime Research Fund, which is, I believe, partly generated even through some taxation to the fuel that is carried. For example, I happened to see in one of the previous president was not in this conference. I was told that $2 cess being charged for every ton of fuel that is moved around the globe. You can imagine with the millions of tons that is moved around, what kind of corpus is going to get created for this R&D thing. But then these are all garnered only by, or mostly by R&D entities of advanced countries, because they have the technology, they can produce the results. And in fact, our share in utilization of such international fund are rather very limited, you can say. Basically, we are not in a position to compete internationally and secure such funding. The fund that we too contribute basically to create. I hope similar conferences be organized more frequently, because that will help in this direction. The organization and the participation of such conference will go a long way to get our standards, that is the Indian research standard, on par with the international levels. Okay, with this, I wish to thank the participants and the organizers, the School of Marine Engineering and Technology, especially Dr. Sivasamy, for engineering such a wonderful event. Thank you. Thank you very much.
Thank you, sir. Now over to Dr. S. Thangalakshmi, ma'am.
Thank you all. All the participants are given a feedback form through our email IDs. Kindly fill it up and send it back to us. We are very much eager to take your valuable suggestion, and we would be sending the hard copies of the certificate to the postal addresses given. Also, the e-proceedings will be sent to you. I can project some of the certificates for you. Of session 1, I'm showing. And we will send the e-copy of the proceeding.
Ma'am, please present.
Yeah, it is not presented. Sorry. Yeah. And we will send the e-proceedings also. Thank you very much for all the participants for your participation and for sharing your ideas.
Thank you, ma'am. Gratitude is the fairest blossom which springs from the soul. On this note, I invite Dr. S. Thangalakshmi, ma'am, to propose the vote of thanks.
வெயிட் பண்ணுங்க. Thank you very much. for this two-day national level e-conference from the participants and faculty members, delegates. So all given the wonderful support. So we are coming to the end of the conference, day 2. So before going to vote of thanks, I would like to announce a small announcement. In the year 2021, month of October, we are planning for international conference on behalf of School of Marine Engineering and Technology, Chennai campus, with the permission of our campus director and authorities. Thank you. Ma'am.
Thank you, sir. I now invite Dr. S. Thangalakshmi ma'am to propose the vote of thanks.
Good afternoon to all. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. There is a saying, God has two dwellings, one in the heaven and the other in the thankful heart. Let me first start by giving glory to the Almighty for making this event a resounding success. I, on behalf of Indian Maritime University, Chennai, entire fraternity of marine engineering and technology, participants, and on my own behalf, extend a very hearty vote of thanks to our Honorable Chief Guest, Shri Uday Purohit, President, Institute of Marine Engineers, India, for gracing the function with his presence and for the enlightening keynote address. Thank you, sir. I'm extremely thankful to our guest speaker, Captain V. Ramadas, Director, Synergy Maritime Private Limited, Chennai, for his dignifying presence and for the inspiring and thought-provoking speech. I'm grateful to the session chairs, Dr. Captain S. Bharatwaj, Masa Maritime Academy, Chennai, Dr. N. Vedachalam, NIOT, Chennai, Professor Dr. S. Muhammad Ali, Pondicherry Engineering College, and Sri Pavan Kapoor, Managing Director, ISF Maritime Services Private Limited, Mumbai, for their valuable suggestions and remarks to the participants. I would like to express sincere thanks to our Honorable Vice Chancellor, Madam, for the generous support and guidance extended to all of us. Thank you, ma'am. We are grateful to our beloved and enthusiastic Director for the guidance, directions, and encouragements in all our efforts. Thank you, sir. I owe a special gratitude to our learned head CTCE and academics for his gracious presence and for the valedictory address. Thank you, sir. My heartfelt and sincere thanks to our HOD, Captain of the ship, and convener of the conference for all the efforts he had taken to give shape and structure for this entire event and for having given me an opportunity as a coordinator of this program. Thank you, sir. I extend my gratitude to the heads and faculty members of all schools of all campuses for their presence and contribution. I express my sincere thanks to all the participants who had connected to our forum across the country despite their busy work and for making our program very lively and informative. I will be failing in my duty if I do not convey my deepest thanks to all the cadets of SMET. They made this event memorable with their support and presence. The anchoring team and the artwork team deserve special thanks here. It's my privilege and duty to thank all the supporting staff for their involvement and support. I thank our IT team of Chennai campus and headquarters for their immense help and support rendered. Now I convey my earnest thanks to the admin and finance team for the timely support, service, and assistance. I also thank the estate officer and team for all the logistic support. I convey my deepest thanks to the Institute of Marine Engineers India for the prominence given, and big thanks to National Institute of Ocean Technology, Chennai, for the sponsorship. Last but not the least, I thank all the distinguished invitees present here accepting our invitation. Once again, I thank you all for your attention. Thank you.
Thank you, ma'am. Events like this are milestones on our educational journey. So let's conclude a remarkable and knowledgeable experience with gratitude. I request everyone to rise for the national anthem.
जनगणमन अधिनायक
So now we are end of the two-day national level e-conference, day 2. So concluding this conference. Thank you very much, all the supporting team and our comparing team. Thank you.
Thank you, sir.
Thank you, sir.